And good morning, good afternoon, good evening to everyone that's joined in for today. Okay, so let's kick things off because we have a really exciting session for today. So today we explore the fourth pillar of the Early Warnings for All program, and the theme is preparedness to respond. So this approach is specifically concerned with those factors that ensure that successful translation of early warnings into life-saving action. So we're really excited with the keynote presentation from Emma today, and a lot of very interesting oral presentations as well as poster sessions. But before we go into the official session, there's just a few housekeeping. So kindly note that this session is being recorded. Please be mindful of your microphone. So if you're not speaking, please make sure to mute yourself. And yeah, familiarize yourself with the platform. There's a chat button down there. You can use this to introduce yourselves, and you can use this to ask questions later. So the conveners will monitor the chat box for any questions that we can put up to our speakers. So hopefully we have a great interactive session today. Yeah, and so what will happen today is we'll start with a presentation from Emma, and then we'll have our oral presentations. We'll have a short break, have the second set of oral presentations, and then we'll do the poster presentations in Gather Town. So this is the fourth session, so hopefully you've been into the 3 other sessions as well. And just to remind everyone, we do have a Slido link, and you can put up your thoughts, comments, questions that would have popped up while we're going through the sessions this last few days. So I'll just put that up on the chat box. So feel free to pop anything there that will be quite helpful for our workshop session on looking into the conference. Okay, so without delaying any further, I would want to introduce Emma Hudson-Doyle, our speaker for today. So Associate Professor Emma Hudson-Doyle is based at the Joint Centre for Disaster Research at Massey University, Wellington, New Zealand. She is an expert in disaster research and science communication. But she also holds a very interesting background because she also has studied volcanology, resilience, and geophysics. So Associate Professor Hudson-Doyle, her research really advances our understanding of natural hazards and how we can effectively communicate science, risk, and uncertainty to the broader community. Very fitting for our theme of preparedness to respond. So she is also the editor-in-chief of Applied Volcanology and a key member of New Zealand Science Communication Network. So she's really interested in bridging this gap between research and public understanding. So over to you, Emma.
Oh, kia ora. Thank you, everyone. I'll just share my screen. First of all, thank you all for having me along today to present, and I'm looking forward to sharing with you some of my thoughts around uncertainty, and then also really listening to that great lineup of presentations afterwards. So today, I wanted to talk to you a bit about scientific uncertainty and some of my thinking and some of our recent research around effective communication of uncertainty. And to do this, I'm going to talk you through 2 slightly different studies that we've done recently, because there was anyone that knows me knows that I will talk for hours about uncertainty. In 20 minutes, I thought I'd focus on 2 studies instead. So one of the things I like to do first is just to take a step back and think, what is uncertainty? Because we talk about it an awful lot, we need to do it more effectively, or we're uncertain about this decision, but what really is it? And I think sometimes when we take a step back, we can really understand how uncertainty can cascade. And it's not just within the advice or the communication, but it's the wider system as well. So we might have uncertainty about what we should do. So it's in the context of action. So that can create doubt, which is its own source of uncertainty. We can have uncertainty around incompleting and conflicting information or advice. It can sit in the data and the knowledge and our understanding. And it can also sit in the interagency uncertainty around who to communicate with and what kind of response expectations they might have. Now, in general, uncertainty when it comes to information and in the kind of risk and crisis situations can cause anxiety and stress or discomfort, fear and doubt, but not always. It can also be incredibly motivational, particularly if you've trained or primed an audience. So to start with, I wanted to just give you a little kind of little tiny example of the importance of how we phrase uncertainty and how it impacts decisions. So this is actually based, a little pilot study I did a few years ago, but it's actually based on Smithson's work in 1999, which is a really beautiful study where they've looked at conflict and ambiguity. So if we were thinking about a conflict scenario, we have forecast A predicts a cyclone is most likely to hit Townsville, while forecast B predicts it's most likely to hit Ayr, so a different location. In the ambiguity scenario, we'd say forecast A and B are both predict that the cyclone is most likely to hit either Townsville or Ayr. Now, when you ask people to kind of rank which one they think is more likely, which one they have more confidence in, overwhelmingly, people prefer scenario 2, and this has been repeated in a bunch of different psychology experiments with different scenarios, not always in like kind of a forecast situation, but other decision-making situations. And they prefer scenario 2 because they rank it as being more believable, it inspires more confidence, or is seen as more trustworthy. And the reason behind this is that people tend to prefer high ambiguity rather than high conflict. We have a conflict aversion. So we'll reduce conflict over reducing ambiguity. So when we think about other areas where we might be communicating science across different studies, different forecasts, different models, people tend to prefer when we're saying all experts agree that the study's findings are different than to saying half experts say X and half experts say Y, which is a conflict scenario. So this is just a really nice example of how the way in which we frame uncertainty has a really big impact on the decisions that people make. And it seems like a fairly minor thing, but it can really shift people's decisions. So I'm going to talk to you today about 2 studies. So the first one is some mental model studies that we've done that have looked at the why behind some of this. Where do people think uncertainty is coming from? And then what does that mean for how we communicate uncertainty when it's present? So what are people's prior perceptions, essentially? And the second one is a visualization study, which is a real classic, looking at, how do we portray uncertainty in a visual in the case study of some severe weather outlook maps. And I thought there were 2 nice examples of the challenges around communicating uncertainty. So first of all, thinking about these mental models, so identifying where people think uncertainty comes from. We know that how people respond to an uncertain statement is influenced, their interpretation is influenced by how the information is framed, cognitive and social factors, and the expectations of their message content. And so uncertainty can devalue a message if it's present, and it can also devalue a message if it's not present. And a lot of that is due to the individual's prior perceptions of whether they think it should be there or not. But the thing is, and studies have identified that. There's a very good study by Rabinovich, and I've forgotten the other author, who actually kind of really dug into this, how people respond to whether or not uncertainty is present and how that relates to their understanding of science. But one of the things is we have very little understanding of how people using hazard science, so whether that's weather, earthquake, volcano, across all the disciplines, understand uncertainty. So we wanted to understand the diversity in people's mental models of scientific uncertainty. So a mental model is essentially how they think the world works. And it's important to understand this because it can help us to improve our communications. If we have a better understanding of where people think this uncertainty is coming from, we can actually frame our communications better to adapt for that. So we conducted some interviews in kind of tail end of 2020 through to 2022. They were 3 phases. So they were, the first phase was free thought response, direct elicitation, asking them to define uncertainty. The second was this mental model mapping and brainstorming exercise. And the third one was more of a semi-structured phase, looking at how they understand how science is produced and their views around communication. And I'm going to be focusing just on the first 2 phases here today. We had 31 participants in total. We actually did it in 2 phases. We had 25 participants to start with, and our goal was to have a mixture of scientists, legal, public, and practitioners, so that the breadth of people you would get in a response, we were really keen on getting that breadth. However, we had to add an additional 6 participants because a lot of the people that we thought wouldn't have much science background would turn out to have a PhD in a science discipline or something. So we had to retarget our sample. We did a reflexive thematic analysis, so we coded the interviews and the maps. And we found 3 main themes around where they think the sources of uncertainty come from. So firstly, they thought that it came from the data. Now, this is fairly intuitive. I think most of us would think, oh yeah, if I'm given a piece of uncertain information, an uncertain forecast, model output, or risk assessment, or a long-term forecast, I'd understand it to be, you know, that uncertainty would relate to the data. So they talked about there not being enough data, that the events, the uniqueness of the events that we're looking at, so the spatial and temporal context, the layers of complexity, and just the fact that a lot of our observations they're non-replicable. You know, these events, no 2 events are the same. And also they talked about the interpretation of the data, so that there was no one right answer, and understanding how something is being interpreted and who is in the room. So they brought that into their understanding of the uncertainty in the data coming to the table. They also talked about the actors. So this is the scientists. So they talked about a source of uncertainty being the scientists themselves, you know, whether they trusted them, what kind of scientific method they were using, trusting the science versus the individuals, the motivations that scientists may have had. They also talked about the media. So in terms of, you know, which expert is being interviewed, that creates uncertainty for a number of people if they're using the media as their primary source of science advice. And that ongoing challenge of false balance. And then they also talked about the salience, so the kind of the communication and the communicators, like how salient is that message? Do they understand the language? You know, they've talked about meaningless numbers or statistics. You know, what is this 1 in 50? Are they talking about timing? Are they talking about size? And then they also talked about known unknowns, so the range of outcomes. So for a natural hazards event, you know, when and where and who, who's giving this advice, who will be impacted, the disciplinary differences that emerge between the disciplines involved in assessing this particular piece of science, this hazard science. The human responses, so how that impacts decisions and influences risk assessments. And the unknown, so the temporal specificity of our knowledge, the constraints, the fact that we conduct all of our science within the environment of time. And all of this, you know, as when we were analysing this data and when we were conducting the interviews, we were all very surprised at just how broad all of our participants went when they were defining their sources of uncertainty. They weren't talking just about data. You know, they were going really broad about the social context of how we conduct our science and understand it. And there were a number of cross-cutting themes. So governance and funding came up as a source of uncertainty, the communication network, the outcomes, how the science links to the kind of outcomes of where the science is going, the emotions. This was a really interesting one. Quite a number of participants brought in emotions as a source of uncertainty, you know, associated with science advice. The time and the time frames, trust, and societal factors influencing the science advice. And this is important to understand, you know, even if we're thinking about a short-term warning that where we have different ways of portraying the science in that, the uncertainty in that situation, a lot of that sits on that background, that foundation of how we're communicating our science in the days, weeks, and months, how we're communicating weather information, forecast information, risk information. And so if we can understand how people understand that context leading up to it, it can actually help us communicate in those short-term situations. So during this process, the participants also we did interview discussion and semi-structured interviews, but they also mapped out. So I've got here an example of some of the maps that these participants produced. So the paper maps were when we were lucky enough to interview people in person. The digital maps are when there was COVID lockdown, and so we were interviewing them virtually over Mural and Zoom, which actually worked really, really well in the situation. And so we actually divided our sample up into scientists, science literate, and lay public, because we wanted to know, how do the map structure differ depending upon the scientific expertise and experience. And so the scientists were those that were practicing scientists and highly trained. The lay public were those that had little to no science training since high school, and the science literate were those that kind of sat in the middle. So they may have done science training a couple of decades ago, but they don't work in a science space, or there may be someone who hasn't had science training but is very science read. And these are the kind of, this is an example of the collective map for the lay group. And I say the collective map, they didn't all work on a map together, which you do sometimes get with kind of group mental model processes. This is more the reflexive interpretation that we went through, where we looked at, the 10 lay public participants, and actually looked at the common themes that were coming out and how they had connected them, listening to conversations. So it's an interpretive map of like the key of the 10 discussions as such. And I think what the main thing to take away from this is it's a big web of connectivity. They talked about everything's connected. It's all connected. The scientists are all connected. The uncertainty is all connected. It all feeds into each other. They couldn't find a way to articulate or cluster, because we asked them to cluster, brainstorm ideas of where the sources of uncertainty are and then cluster them together. They weren't really able to articulate that. They had all these ideas, but it was kind of a mass of information relating to trust and environment and media and the researcher and the data. Then when we looked at the science literate group, we could start to see it was starting to organize a bit more. So they were saying, there's talking about lack of understanding and knowledge, and then the societal aspects and the media, and then the kind of role of the scientists and the agencies, and politics started coming in. It's starting to rationalize and form a more structured model. And the third group was the scientists group, and they were the most organized. Their maps were incredibly organized. They had a flow, they had a structure, things were clustered. And you could start to see that there was a cluster around researchers. There was a cluster around the kind of the local context and the translation of science. There was a cluster around the hazard and the hazard impacts. And they were very clear about the links between things and how one source of uncertainty depended upon another. So what are the main key take-homes from that? These look like kind of, webbed maps and unclear. And it's less about the individual maps, and it's more about the differences that we were seeing, and particularly the way people were talking as well. And what we noticed from the discussions and from the maps was that the map organization, the structures that people had for their mental models of scientific uncertainty, increased in organization with scientific experience. And that occurred whether or not they had a training that was in physical science or meteorology or natural hazards. It was just if they had a science background, they had a more organized way of thinking about uncertainty. And this is very similar to something that's called chunking in the kind of psychology and educational literature, which is where we, as our experience increases, we prioritize patterns and organization. So this experience influences how we assess our information. So for those that were less experienced and had less organized, structured mental models, they relied more on situational factors like the trust that they had in the agency than they did in the patterns and sequences that they had been taught. They also relied more on what's called tacit knowledge. So this is this kind of knowledge that's hard to articulate. Like we can't describe how we ride a bike, but that's kind of, it's like inherent knowledge that they've learned from elsewhere to actually interpret this information more so than the scientists who use kind of more formal structure to describe uncertainty. Their focus of what they talked about was very different. The lay public talked more about control and safety and trust, where the scientists talked more about kind of formal models of risk and likelihood when it comes to uncertainty. The role of language was really important. It was very clear that those people that didn't have terms to describe uncertainty and describe the science couldn't articulate their mental models. They really struggled. They needed the language to actually articulate what uncertainty, where they thought scientific uncertainty came from. what does that mean for us as communicators? First of all, I think we need to develop understanding of the other knowledge that people are using to influence their interpretation. So the other knowledge bases they're drawing, so that they have a situation, they don't have a structured mental model to understand it. They'll actually pull from other places, other domains, to help them understand. So we need to build up a bit more understanding around where else people are encountering uncertainty and what that means when they're dealing with, say, an uncertain weather forecast. And then we also need to, where appropriate and if time permits, include information about the process by which the science has been developed and the uncertainty has been developed to help support pattern recognition. And so this is something that's kind of was emerging out of some of those discussions with my colleagues in the psychology field around, if we can give them information to support the development and update their mental model, that may actually help them enhance their understanding of this scientific uncertainty. And that's particularly important for changing risk, new information, and when we have different analysis. But of course, it depends upon context and time. And it's a really delicate balance because, you give people too much information, it's going to lead into information overload. So like, what can we be doing in those early education efforts that can help people understand a bit more where this uncertainty is coming from, so they don't just discount a message when it has uncertainty in it. So that was one example, study one, which was about kind of what's going on inside our heads when we're thinking about uncertainty. And I wanted to give in, some of the talks that we've got today. I also wanted to give a little example, and I'll talk through this fairly quickly, around a study we did on the visual design of severe weather outlooks. Now, this was led by Marion Clive, and Marion and myself were working on really trying to understand how we portray uncertainty in space and time when it comes to a weather outlook. And I thought it was a nice example to show. So these are severe weather outlooks as they existed up until last year at the Met Service here in New Zealand. And we were in a study where we changed the design of these outlooks by tweaking some of these uncertainty elements. And it broke people up into different experimental groups, and they were given different visual displays. So first of all, we had a time frame visualization. So we had 3 conditions for the different ways of displaying forecast time. And then we asked some questions related to, comprehension, when did they think something was going to happen, their perceptions of likelihood, and their ease of reading. And so on in the one map we were given was one which just had, so it's a 4-day scenario, Waitangi weekend, different likelihood of rain, different levels of confidence of rain. We had the 4-day scenario all on one map. We had another one which is a little cycles through each day. And then we had another one which is where each day was a separate map. And what we found was that we got more correct responses for people when the group was represented with this display that you have before you. Now, the composite map, the first one, people had higher levels of concern and higher perceived likelihoods of the severe weather, and they were more likely to change plans, but they're actually were indicating whether severe weather may occur on days when there wasn't likely to be severe weather. So they were merging it all into one thing. Whereas this one, they actually got more effective, more better, more accurate responses. And so this is actually being rolled out now in the Met Service here in New Zealand. A similar study was looking at another part of the study. We were looking at how you look at confidence and whether you use outline shapes, colored shapes, whether you write confidence or whether you use a little logo on the far right instead. So whether you explicitly write it on the map or whether you use a logo off to the side. And we found that the solid shapes were associated with higher estimates of confidence. There was when we wrote the extrinsic uncertainty, so when we explicitly used text, we got ones that were closer to the definition. The ones that reported the highest ease of reading was actually this middle map, and the lowest levels of reading was the one on the right. And lastly, we looked at how we can tweak weather icons. So whether you have little rain things or whether you say it's going to rain, how you change the colors and stuff like that to convey the different levels of confidence. And we found that the icons improved the ability to distinguish the number of weather types, but it didn't improve the ease of reading. People found it cluttered their kind of understanding. It didn't really aid comprehension. So that one needs a bit more research. So the key take-homes from this visual design, which is, was that we found it was really important when you have uncertainty in a forecast, and the uncertainty exists in a time frame, that it's good to communicate one day at a time. And this is kind of sits quite similarly with some of the stuff we've seen in volcanology when you have time forecasts, where it's really important to include a forecast for a near-term window as well as a long-term window. So this idea that we can't just mush it all together into one forecast, that people need that kind of aggregation, not aggregation, segregation of time windows. We need to be explicit about the uncertainty, so use extrinsic expressions, so text, and that supports more accurate interpretations. The importance of consistent visual design, so these salient shaded areas can be associated with higher levels of perceived forecast confidence than those areas that had outlines, but whatever we do, we need to be consistent across it. And the icons can be really helpful because they can aid comprehension, but they should really always be tested because of the fact that some people found them, that gave them real visual clutter and confusion, and they found it much harder to understand the icons. So I've given you an example of 2 different studies, and this is my last slide just to kind of go over some final take-homes on communicating uncertainty. So firstly, I just wanted to really reiterate the importance of acknowledging uncertainties, and that because it can actually help with the decision making in appropriate context. And this idea that you need to be thinking about your audience a lot when you're deciding how much to convey. To have traceable accounts of uncertainty evaluations, whether or not you necessarily go on to communicate that. So this came up recently here in one context, in a seismic context, where it's really important to kind of always have those traceable accounts of uncertainty available. Standardizing the language to represent uncertainty because of the disciplinary and contextual differences that exist. Communicating a degree of confidence in any analysis. When we have probabilities, like I was saying earlier, the importance of reporting forecasts over a range of relevant time windows. If time permits, communicating the social history of uncertainty, and that helps with that first study where people were talking about, but I expect this uncertainty to be coming from governance. I expect it to be coming from funding. And so people want to know that more to understand the study. But of course, that's very important to understand when to communicate that level of information. To evaluate communications, communicate the source of uncertainties and when they can be reduced, which is really key, and to be led by the decision makers' perspectives and needs through decision relevant communication. And that's me. Okay.
Thank you, Emma. A really interesting presentation, and I think everyone else in the audience is quite fascinated by the findings. So we do have a few questions in the chat. I'll just read Andrea's questions. So these findings are really interesting. Can I ask if the science literate group were organizational decision makers? Thinking about this in terms of operations or particular org sector, or are there members of the public who have greater experience of scientific concepts?
There was a bit of both, but overwhelmingly there were more the organizational decision makers. So they were the people we spoke to were policy writers, planners, emergency managers, various kind of people from like CDEM, NEMA, a range of decision makers. But we did have a few of the public in there as well, because we were considering decision makers as a public. So there were a few people from the public, not many, but just a couple that sat in that science literate group, because they did actually, in the end, even though we had recruited them as a public member, they actually had a lot of science background. So there were a couple of them in the science literate space. Yeah.
Thanks, Emma. If anyone else has more questions, please put them in the chat box, but I'll go to the next question from Beth. And she's saying, thank you for sharing your results. The visual designs, what is the significance of the chosen colors, if any? And she might have just missed it.
Yeah, so I'll go back to the colors again. There was a there was a significance. The main thing was around the importance, of course, of different colorblind checkers, so getting high contrast difference between the colors for different colorblind checkers, and then going through the color picker around making sure that they were the different shades, trying to avoid the red color, although that was quite difficult because of course the pink felt quite similar to red. So trying to avoid a sliding scale for this this one in particular in the middle was because we were going for a high contrast color. Whereas on the right hand side, we were looking more at how people respond when you're looking at like shaded color. So, you know, you're going from lighter color to darker, but you're staying within the same color frame. We had quite a few discussions about this, and I'd have to remember to chat to Marion how we came to the final decision, because it's a really good question that there was a rationale behind it. But I know that the middle one was about the high contrast differences, and the other one was around the scaling up through them. There was an option, of course, also to look at your kind of red greens and stuff, but we were avoiding red and green because of all the connotations that red and green already have. So it's quite interesting when you get the color chart out, how many you almost have to throw out, because you're like, that already has so many meanings in different cultures, so we can't use that color scales and we can't use this color scales. So this was kind of chosen as a happy medium.
Thanks, Emma. And really interesting question. So in your introduction, you talk about people preferring ambiguity to conflict. So is it consistently true that people prefer ambiguity to conflict? Do you notice any particular groups where this may not be the case always?
I think I think most of the results show that the majority of people prefer ambiguity to conflict, but there's always that 20% of your sample, or I don't know the exact numbers, but when you look at the studies, it's like it'll be 8 out of 10 or it'll be 7 out of 10. So there's always these people that actually think differently, and I guess that's one of the challenges with all these studies, is that we're trying to pitch towards the majority. I don't know which particular groups, but it is a really interesting question, because in some of our lectures and courses here, I often turn that into a student exercise. So I put the question up, and then I get the class to vote as to which one they prefer. And every like 4th or 5th class, when I do that, they'll actually prefer the conflict scenario. And I've never quite understood why, but so it is that there is a portion of people that prefer and choose the conflict, but the majority will choose the ambiguity. I think it would be really cool to actually dig into who chooses one over the other, actually, and if it's a training or if it's a different disciplinary, like how they work, what their day-to-day job is like. So yeah.
Thanks, Emma. And a question from Everisto. Was trust on uncertainty framing different amongst the different study groups in the first case study?
Yeah, so the lay public really used trust and referred to trust an awful lot more, overwhelmingly more, than the scientists. The science literate talks about it a little bit, but not nearly as much as the lay public. And we've interpreted that to mean to relate to what I was saying about how, because they didn't have such a formalized understanding of the science and the scientific uncertainty, they need to rely on these other societal and social factors to identify, to understand and interpret and assess that information. And so thus they're talking about, if I'm in an uncertain situation, I'm given uncertain advice, I'm going to just trust what the scientist said. I'm going to have to think about what, rely on what those scientists or who's communicating it to me. How much do I trust this scientist? How much do I trust this agency as to whether or not I'm going to, be comfortable with the fact they're giving me this big piece of uncertain advice? Yeah, so it was really different for the lay public.
Yeah, thanks, Emma. We're almost out of time, but my kind of really thing that I took away from the presentation of the difference between the different groups of the interconnections in that mapping models, and I think it kind of really highlights the importance of the prior perception, and they're like different knowledges, I guess, other knowledges that influence how we understand what is being communicated to us, and I think that's really kind of key to understand how we can communicate better, but also how do we prepare our communities better so that they can respond and make those decisions. So I think that's a really great presentation, very interesting cases as well. So really thank you for your time. Hopefully you can hang around a little bit. Maybe some people have more questions and they might pop it in the chat. And really thank you for your time.
Yeah, thank you everyone. Yeah, I'll be around for the most of the rest of the evening, afternoon, day. I don't know what time zone we're all in. Thank you.
Okay. And now we're moving on to our oral presentations. And the first presentation will be from Andrea Taylor from Leeds University. And I'll give you the floor, Andrea.
Thank you very much. So good morning, afternoon, or evening, wherever you are. Today, I'm going to be talking about a project that my colleagues and I are in a comparatively early stage of, in which we're focusing on utilising the World Risk Poll to assess predictors of risk perception and preparedness across the world to develop more effective strategies for weather risk communication. So this project has been funded by the Lloyd's Register Foundation, who commissioned the World Risk Poll as part of their Turning the World Risk Poll into Action scheme. Now, there have been quite a number of projects focused on multi-hazard early warning systems as part of this scheme. So there may be quite a number of these that are of potential interest to people in this conference. So I imagine that I don't need to explain to this cohort why it's important to focus on the communication of weather risk, but just to emphasize, over the last 50 years, the WMO has estimated that there's been over 11,000 reported weather, climate, or water-related disasters that have resulted in just over 2 million deaths, and as well as over $3.6 trillion in economic losses. So the scope and the stakes involved are really, really huge here. Now, something that we know is that changing climate means that the frequency and severity of weather-related disasters is set to, unfortunately, increase in many regions of the world. So this makes developing effective early warning communication a real priority in order to reduce harm to people, property, and infrastructure. However, in order to do this and to ensure that our comms are appropriately tailored to the public audiences that are receiving them, we need to understand what the current drivers of weather and climate risk perception, as well as weather and climate risk preparedness are across the world. So in these different contexts where we're communicating. So our project focuses on this, and we are drawing on an existing data set called the World Risk Poll, which, as I mentioned, is commissioned by the Lloyd's Register Foundation and conducted by the research company Gallup. It has so far been conducted 3 times, once in 2019, 2021, and 2023, with another round due in 2025. It contains representative national samples across more than 190 countries, so resulting in over 100,000 participants globally each wave. And it contains items related to things such as demographics, which we'd expect, questions related to climate and weather risk perception, questions on risk preparedness behaviour, and beliefs about governmental preparedness, as well as community level preparedness, and trust in different agencies and sources that might provide information about weather and disaster risk. So I've linked here on the slides to the Lloyd's Register Foundation's World Risk Poll dataset, because this is something that may be of interest within this wider community. So in terms of our project, we're currently in the first phase that you see here. So we are utilising the World Risk Poll, we're integrating it with other sources of data in order to assess the predictors of risk preparedness and risk perception across the world. We are then going to use this analysis to select a series of 4 to 5 focal countries, which will be reflective of different country level characteristics, whether this be related to climate, governance, cultural approach to risk. Within phase 3, in around a year and a bit's time, we're going to be looking to develop and test weather warning comms in focal countries with large samples. And then in the final stage, we're going to test hypotheses that we've made within the first 3 phases of this project with the upcoming 2025 World Risk Poll, just to try and validate what we're doing and the recommendations that will be emerging from this work. So in terms of why we think it's very important to look at multiple countries, something that we know is that many standard approaches that use things such as regression analysis when we're looking at survey data are quite good when the relationship between different variables. So I've got here the example of the relationship between perhaps experience of weather risk and perceived risk preparedness, if these relationships are the same across all countries and contexts. So these standard approaches would work quite well. However, it may be that this isn't always the case. It may be that in one country we find that there's a positive relationship where experience of severe weather leads people to report or is related to reporting greater risk preparedness, but then another country where this association is negative. So people who report greater experience of severe weather perceive themselves to be less prepared to deal with risk in the future, which could be due to a number of factors, such as how well one thinks that perhaps one coped or one's country coped with previous events. So we know from the literature that several factors have been linked to risk perception and preparedness, including things such as experience of risk, education, as well as trust in authorities and those communicating about risk. However, we do sometimes find that these results are not entirely consistent across studies. And something we're never quite sure of is this simply how the questions, how the variables were operationalized in each study? So perhaps we're asking slightly different dimensions of trust. Or is this simply because we're doing the study in different countries and therefore the relationship between these things are different? So we feel that it's very important to identify, firstly, which are the generalizable cross-country, cross-culture predictors of risk perception and preparedness, if these exist, and what factors are perhaps more country or context-specific predictors. So by better understanding the latter in particular, it may help us to develop better, more targeted warning communications that draw on, what predicts risk perception and preparedness in different contexts. So by using what's called a multi-level modelling approach that can account for country level as well as individual level differences in responses, we can gain a clearer picture of what predicts risk perception and preparedness. To then understand why country level differences may occur, we are integrating country level information on things such as observed disasters from the CRED-MDAT dataset, government indicators and indices, as well as wealth indicators such as the Gini index and GDP, and indices and indicators related to current and future climate risk. So I realize that this is perhaps a slightly busy visualization we've got here, but I've just shown this as an illustration of what's coming out in the preliminary stages of our analysis. So our preliminary findings are already showing that the relationship between, we've got here the example of reported severe weather experience and beliefs about one's government's preparedness to deal with disasters, that the pattern is looking quite different across different countries. So we have these blue bars that represent people's perception that their government is well prepared, the green bars that indicate that their government is not well prepared. And of course, we've got data points showing those who report experience of severe weather versus those who don't. So we can see now that these slopes are quite different across different countries. And just to zoom in a little, I've just chosen some illustrative examples that really, I would say, emphasize the importance of taking this multi-level approach. So we see here that not only within different countries we find, as we would expect, that There's a greater likelihood of people indicating that they feel their government is well prepared, but the relationship between reported experience and perceiving one's government as well prepared or not really differs between different countries. So we see that that there's a negative relationship in Turkey, but in the United Kingdom, for example, this doesn't seem to really make so much difference whether you report experience or not. So this really underscores the importance of taking this country level approach. And of course, at this stage, we don't know why we might be finding these differences, but through further analysis, further integration, integrating the sort of data sources that we've already integrated with the data set, we hope to gain a clearer picture of this. So in summary, we know that developing effective multi-hazard early warning systems does require an understanding of the predictors of risk preparedness. Our early findings were already showing that there's quite high variability between countries in terms of the relationship between reported experience of disasters and different risks and perceived national level preparedness. We have similar findings for individual level preparedness and perceptions of community level preparedness. So through continuing to explore these in more detail, we are going to try and select a set of 4 to 5 focal countries with different characteristics representing these different types of relationships in terms of predictors and experience. However, we're not going to rely just on the outputs of our analysis for this. We're also seeking input on the process from the wider disaster risk reduction community and those involved in multi-hazard early warning systems. So I'm happy to take any questions if there's time. I've also got a QR code if anybody wants to leave any comments after the session or wants some further information about the project. Thank you very much.
Thank you, Andrea. Really, thank you for also keeping to time. And we do have some time for questions. So feel free, anyone, to raise your hand if you have a question or put it in the chat box. But yeah, I have a question while people are thinking. So it might be a little bit early to kind of, at the stage of your research, to decide what countries that you're looking into. But you did mention kind of specific characteristics that might help you define which countries that you're gonna look into. Is there kind of, can we have a, a preview of this, some characteristics that you're looking into?
So, I mean, obviously, the plan isn't that this isn't just going to be based on statistical analysis. We do want to include countries, firstly, in both developed and developing countries, which may have may be at quite different stages in terms of national weather warning services. But then there might be characteristics such as local climate, other characteristics such as perhaps, I guess we could say, cultural approach to risk, things that we might find do appear to be associated with risk perception and preparedness, and therefore, as I say, the goal is really to try and get a set that captures a range of contexts. So we're hoping that perhaps by looking at these relationships, that this will give us an indication. Statistically, we are still working on this, but we hope to have much more to report soon.
Thanks, Andrea. It's a really interesting study and looking forward to know more about the work as you course through the next few years on working on this project. So we have a question. Are you able to say anything about whether beliefs about preparedness correlate well with actual preparedness of a country? Your survey seems to focus on beliefs rather than, I guess, the actual preparedness.
Yes. So in terms of, obviously we know that perceptions don't always match objective or quasi-objective measures. So within the survey, obviously, because it's a survey, we can only ask about national level preparedness and community level preparedness. We could cross-reference this with things such as disaster indicators, governance related indicators. Now, one of the items that we are using as a proxy for individual level preparedness on the survey is a question about whether a household has essentially a plan for disaster. it's quite a general question, but it does serve as a good proxy in terms of something that people can report on that they actually have or don't have.
Really interesting. A question from Victoria: Will you be able to tell if the recency of people's experience influences their perception?
Yeah, so because we are able to look at multiple waves of the survey now, obviously these waves are not with the same people in each case. It is a repeated cross-sectional design. Something that we hope to be able to do is to actually have data on, or information on, where disasters have happened in the world, perhaps in the period between studies, and examine whether this proximity could potentially be influencing risk preparedness as well as risk perception.
Cool. One final question. Do you have any data in the WRP on how perceptions might differ between countries in terms of how local authorities are prepared? For example,
so I believe that within the data set that there are questions that ask about local level preparedness. So the ones that we've looked at, as I say, are national government, community level, individual household level. Off the top of my head, I cannot immediately recall whether there's anything about local government. However, as I mentioned, the data set is open access, so it could maybe that you could look at the what's in there and see if there's anything useful.
Cool. Yeah, so there are further questions in the chat, so if you could answer them, Andrea, and get some maybe some more interesting questions in there. So thank you for your presentation. Really looking forward to the next stages of your research. So if we have next, we have social contextualization of early warnings for all, and this will be from Biswanath Dash from Birla Institute of Technology and Science from India. So
thank you so much, and thank you, Jelmer, also for the correspondence we had and for the opportunity you have given me. So I'll just come back from Andrea's excellent presentation, global poll, to a very local context, and this time it is in Orissa in India, that's in the east coast of India. And my presentation is about social contextualization, early warnings for all, and we are based at Hyderabad in India. As we all know that this EW for all was launched in 2022, and it aims that everyone on the planet is to be protected from hazardous weather, water, and climate events by 2027. I've italicized protected because that's something we want to problematize, or to ask questions like, what does this protection mean, or how does it happen in practice? And the argument is that the protection need not necessarily only vary across hazard context. In our case, it is a tropical cyclone, and we find that a varied level of protection is understood as far as evacuation is concerned. So therefore, I'll come back to this term a little later. And just to put the case in context, we have this CRED data that over the period of 20 years, 95 to 2015, the storms generally have accounted for the one of the biggest contributor to the global death, about 242,000. And even in the last year itself, there were about 43 tropical cyclones. That's quite surprising because the storm warning considered to be historically one of the earliest to have taken shape, going back to the 19th century. So in spite of having one of the longest serving warning system, we continue to suffer that number of losses on a routine basis. And I link it to a particular gap that was identified in the last Weather and Society conference. So it's need to better understand the contextual factor which are affecting the user response. So in our analysis, we put this contextual factor to understand that what are facilitating and which are constraining as far as a public or user response is concerned. And we try to do that with the help of a case study, that's Tropical Cyclone Fani, which hit Orissa coast in May of 2019. And I'll just provide a little more details about the particular cyclone, to get into the response part of it. As this particular, this is from Indian Meteorological Department, and you can see this happened over a period of 8 days or so. 25th of April 19, it was first detected as a low pressure. And then he moved on from the 26th of April depression, continued to move, become a cyclonic storm on 27th of April. And thereafter on 29th, it becomes a severe cyclonic storm, becomes an extremely severe cyclonic storm, which is basically 167 kilometers per hour above, right up to 221 kilometers. That's the second highest category as far as this particular scale is concerned. And this goes and hits Orissa coast in a place district called Puri, and just around a lake called Chilika Lake happens to be the largest brackish water lake in Asia. So this is just next to the Chilika Lake, and it happened in the morning of 3rd of May on 2019. And at the time of landfall, it was about 175 kilometers per hour. Now, as you can see, the landfall happened after a sort of turn, and the IMD did pretty well in terms of providing advance warning over several days. And during this time, they issued about 269 different bulletins. In addition, they gave social media, SMS, press briefing, etc. This slide gives you a sense of what was the impact of this cyclone, or called Cyclone Fani. And these colors are basically saying this is the most impacted area, or called extremely heavily affected area. That's the Puri district and the surrounding region where the landfall occurred. And this is about more moderately affected, and the remaining are only affected. Together, this affected about 14 out of the 30 districts of the state. A total of 64 people died, and most of 39 of them died in Puri districts where the landfall occurred. And the number of affected is about 16.5 million, 3.62 lakh houses were impacted, 1.55 million people were evacuated. That's a phenomenally high evacuation number, and the government has been appreciated for its effort. That's about over 15 lakh people evacuated to about 9,177 shelters. And that's a tremendous effort as far as reducing the number of deaths. If you look at the Puri district, which is what we went to study, and we conducted field work in about 15 odd villages, and mainly through the focus group discussion, we found that 130,000, that's the official figure, 130,000 people, 130,000 people evacuated, in addition to 25,000 tourists. Puri happens to be a popular tourist place where you have both religious and peace tourism. So there, at this point of time, May is a peak period because of the summer, and there were a large number, 25,000 of them, they were helped in terms of getting out of the Puri districts. In our initial finding, we found this early warning, as I said, came days in advance, and almost everyone received. We didn't come across anyone who said he or she or they did not receive warning, and basically it came through WhatsApp, loudspeaker, sirens, etc. These are two pictures to tell you that as far as the warning at a local level, this is a siren system, and some of the places it worked, but there were occasional places where it did not work. And on the right, you see this is the antenna which was damaged during the cyclone. However, it worked actually previously before the impacts were felt, and this is on top of a multi-purpose cyclone cell. So given this 130,000 people evacuated, the number of deaths being 59, we went with the question, who are those who evacuated and why did they evacuate? And more importantly, why are the others who did not evacuate? Because this happens to be on the path of the landfall. So obviously it's an extremely vulnerable zone, and therefore we expected much more number of people to have moved out to center. But we came back with these findings of it. First of all, the idea of evacuation only sort of was translated to a set of people who lived in Kacha weak houses. And these houses happen to be in low-lying areas and very close to the coast, within a distance of 1 kilometer or maximum 1.5 kilometers. That means all of those within that close proximity who lived in concrete houses did not think that they required to evacuate. So we asked this question, what is the reason for it? Those who evacuated, they said there is a possibility of the tidal threat. Many of them provided experience of previous cyclone, particularly the 1909 one, where they saw that the tidal inundation at least was to a certain extent, and they felt that is one of the biggest reason why I thought the tidal inundation is a distinct possibility we need to know about. However, a lot of them who evacuated, they did not do so for the tidal inundation, as it turns out to be the biggest risk of a cyclonic disaster. They did it more because of the wind and the heavy rain, and to a certain extent, local flooding. That means the second category of evacuees were doing so for a different kind of hazards, which is not necessarily tidal inundation. Where did they go? All of them, mostly they went to public buildings, which are schools, community halls, and some of them are multi-purpose cyclone center. And a few of them reported to be going to the relative house. And as I said, the crucial question, those who did not evacuate, they did so for a variety of reasons. And a predominant factor among is that the houses are strong enough to withstand. The question, however, remains that what is the safety assessed for? Was it for tidal inundation, or was it for the wind and the rain, the other kind of hazard associated? We did not find any sort of clear-cut answer, because it was always seen as the cyclone is more in terms of the wind and rain, except those who are living very close to the coastline who thought that there is a possibility of a tidal inundation. There are those who said that the choices were where they need to go. The shelter obviously is not a very good choice. I'll follow it up with a few examples to illustrate this case. There was this question about social hierarchy in terms of that, the particular society is structured around caste in terms of the social configuration. And therefore, there is also a question about reputation, social, status, and so on. To be in a shelter alongside many others, therefore, is not necessarily a good, easy choice for them to do. Previously came out particularly from the women group, who said that they would find it difficult post to be thrown open in a large group, people inside the shelter. Secondly, there are also the additional burden of carrying out the children's tasks, particularly small children, young children's. How do they take care of them? There was this reference to the fear of theft, and then leaving behind pets and the livestock. This is a picture just to show that that there is a damaged school, and on the other side there is a multiple. They are side by side. A lot of people took shelter in this particular damaged school, as many others did. The primary reason of discussing this that the whole number of people requiring evacuation is so large, there is hardly any scope to distinguish between what is the more safer shelter between the two. Therefore, once as this particular school building got damaged, all those people inside moved in, somehow managed to be packed inside the shelter. And that's a recurring issue at every other place, because the number of people evacuate is so large that requires a different approach altogether. In this big illustration, what I intend to show, there is a multi-purpose cyclone center at a place called Sharpe that's near to Chilika, and the distance from here to the sea is not even 2 kilometers. Right opposite this multi-purpose cyclone center, you find this particular school, which is a primary school. All those people living close to the center, they prefer to take shelter in the school instead of the multi-purpose cyclone center, because the school will provide them food provision because of the government programs is much better maintained, and the school authorities initially gave them this portion of it in order to take refuge. At the peak of the cyclone Fani, this particular roof blew off, and therefore these evacuees were accommodated into the other part of the school. This is again the region that most of this particular one is jam-packed with a large number of people from the surrounding region. In this picture, you see this is more a question of safety, where at the top of a multi-purpose cyclone center, and this excerpt, if I can read out, the center was completed in 2015. About 100 of us were here when Fani made a landfall. Maximum wind speed was 250 to 300 km/h. And that point of time, the shelter was shaking, its iron gate broke open and its glass windows. One person was injured. We are holding each other with some trying to hold up the doors and windows from inside to prevent it from flying out. Of course, this estimation is a local assessment, not necessarily what the IMD has said, but that gives a sense of what the inside picture as far as the multi-purpose center are concerned. This particular boat, in order to illustrate that, is the time. Yeah, sure.
Yeah, 1 minute.
Yeah, sure. This particular picture is to say that when we give warning to the fishers, we have often discussed, what can be done for the farmers, to protect their crop, for example, early harvest, etc. Not much attention has gone to the idea of the features. What can they do once they have a warning? Because the boats are something that can't be, taken away from the beach. And often this boat damage happens because of the collision between the boats where they are berthed. And this is a neglected part as well. So once again, the features are in cutting a situation, neither they can move away leaving their boat. And if they do, there is a damage, and often the damage is not compensated. To conclude, what are the takeaways? One, the first point is about it's a thickly populated coast, and therefore you'll have to trade off between who requires evacuation, which is why we ended up saying that those who are in concrete buildings, they need not necessarily evacuate. It is those who are higher vulnerable, that's in the Kacha houses, they may do so. Second, all available public buildings, as I showed some school buildings, that was not differentiated because we need more number of shelter and the number of multipurpose is only limited. There is a lack of clarity over what this multipurpose cyclone shelter to be used for. One idea is to be used as a self-shelter even at the peak of a cyclone. As I showed someone picture that they can be vulnerable if it is beyond a particular threshold. The second idea is that those who fail to evacuate for a variety of reasons, they may take self-shelter. That clarity is still lacking. The third one, the expectation the public have generally is not just about accessing or getting information, it's also length of the power distribution, water availability, estimated damage to crops, and so on. To conclude, what I want to highlight is that the evaluation of all these warning services, whether it should be done in terms of, as it has been, that is the number of days we have saved or lives saved, or in terms of injuries, but does it require to expand more than that to include a variety of other things in order to make this early warning for all a more feasible solution? Thank you so much, and my apology for crossing over the line.
No worries. Thank you, Biswanath. Really interesting presentation on a case during the cyclone Fanny, and looking at how people evacuated or not evacuated and the reasons behind it. So yeah, I think we have some time for questions. So if anyone has a question, please feel free to raise a hand or put it in the chat. So I have a question while people might be still thinking. So you said that before the cyclone made landfall, there were already several warnings that were given out, TV, in WhatsApp. But what are the, I guess, the message that was being distributed then? Were they being asked, particular people being asked to go to this multi-purpose cyclone shelter? What action was being suggested to the public to take?
So the typical way we work here is that there is a centralized message which gives a sense of the danger in terms of the landfall, the projected wind speed, tidal inundation, etc. And then it is sort of, disaggregated at a local level where the authorities help people evacuate. The general message is that they must evacuate to a safe center. However, what leaves, that gives a sort of, gap in terms of what constitutes a safe center. For example, many feel that if you have a very sturdy building next to the shore, that also can be a safe center because it's pretty strong and can withstand, let's say, 200 kilometers per hour. And which is what I tried to highlight.
Yeah, thank you. One more question from Jelmer. So a really interesting presentation. In one slide, you mentioned there's a trade-off between safety and convenience in shelter choice. I can imagine that familiarity with shelter location also plays a role. And I think this is what you were mentioning earlier. Are there any ways familiarity or training are conducted so that to increase people's familiarity with these shelters? Is there like training, educational programs, things like these?
Yes, but while I have one very sort of specific, there is a training, but not necessarily for a mock drill kind where people know how to take shelter. This multi-purpose idea itself is that they are used on a, for any vaccination program, for any kind of distribution and so on. So they are familiar with the setting of the shelter. However, the challenge becomes at the time of actual disaster like a cyclone and so on, because the shelter caters to a large population and you have no idea, therefore, how many actually will turn up on a given day. And it's more on the side of the capacity. So the trade-off is essentially between the capacity as well as on the convenience side.
Yeah, thank you. That's really interesting because, yes, we can tell people to evacuate, but capacity is another thing that we definitely need to consider. And I think one key thing from your presentation that I took away is this third point that in your presentation that it's quite interesting that the expectation is not just for the warning service itself, but actually a lot of other factors as well, such as, like you said, length of power disruption, availability of food, shelter, water, and all of these things. And yeah, really interesting to see how public expectation versus how the authorities also prepare so that they meet the public expectations so that people will make those decisions for preparedness to respond to these warnings. So really thank you for your presentation. Thank you for this case that you presented to us today. Right, so we'll move on
Thank
to
you.
the next presentation. So the next presentation is from Candice Howarth, and unfortunately, she won't be able to make it today, but she prepared a presentation, a recorded presentation for us, and we will share this with everyone.
Good morning, everyone. My name is Candice Howarth. I'm from the Grantham Research Institute on Climate Change at the London School of Economics. And I'm going to be presenting to you on building a culture of heat in the UK, addressing the country's lack of preparedness. This is based on some research that we've been doing over the last 18 months, and we've just published a report that provides underlying evidence for the research. Now, why is this important? Now, as I'm sure many of you know, 2023 was the warmest year on record globally, with an above average temperature of just under 1.5 degrees. In the UK, 2022 was the warmest year on record, and 2023 was the second year on record. We know that adaptation to current climate impacts is insufficient and that risks are projected to become more frequent, pronounced, complex and difficult to manage. And extreme heat is rising in its intensity, its frequency and its duration. Now, in July 2022, the heat wave that was experienced in the UK was extremely rare. It was a 1 in 1,000 year event, which was made 10 times more likely due to anthropogenic climate change. We saw 5 heat periods over that summer, with temperatures exceeding 40 degrees in England for the first time. And we had a first level 4 heat health warning, which was issued on the 18th and 19th of July. There were just over 3,000 heat-related deaths and widespread impacts to the economy. So why is this important? Well, back in 2022, we saw over 60,000 heat-related deaths across Europe. As I mentioned, close to 3,000 in England, which was the highest since the 2004 heatwave plan for England. So we're seeing impacts on health, but also on mental health, where we're seeing an increase in incidence of certain mental health issues, and it can affect medication and is linked to an increased rate of suicides. It impacts the economy. In 2022, this led to over 11 million potential labour hours lost in the UK as a result of the heat exposure, particularly across the agricultural, construction, manufacturing and service sectors. And it's having a huge cost on the economy, costing up to £300 million per year now, and this is estimated to reach up to £950 million per year by 2050. It's also affecting our buildings and our infrastructure. In the UK, buildings are built to keep people warm in the winter and not cool in the summer. So we tend to see some of those impacts with overheating in the summer. Back in 2022, we saw rails and roads buckling, a surge in water and energy demand, and a range of wildfires, which caused a range of rail and road closures, further impacting the economy. And often the impacts of heat to the natural environment are neglected. Heat and water stress affected animals, plants, flowers, trees and habitats. It affected crops, which then affected food production. And heat, wildfires and drought can reduce the cooling capacity of green spaces, further enhancing the overheating impact. And we're seeing more and more publications that have been coming out over the last few months around why this is important. We published a brief last year which showed that England and the rest of the UK are not ready to respond adequately to such extreme events. National Audit Office, back in 2023, a few months ago, published its report that confirmed that the government has yet to set out what outcome it's looking to achieve, and that there is a widespread lack of clarity. The Environmental Audit Committee just published its report on heat resilience and overcooling and cooling, and demonstrated that we need more urgency and ambition to enhance heat preparedness and resilience. And then more locally, at the local level, the London Climate Resilience Review demonstrated that London is underprepared, as are many of the cities across the UK. So this is an area of importance and increasing significance. Now, what did we do for this research? Well, our aim was to capture the experiences of the 2022 heat waves, predominantly by decision makers, and we focused on England, Yorkshire and Humber, London and Manchester. And we spoke to people who had been directly involved in the responses on the ground. So we wanted to assess whether UK policies are effective when it comes to responding to extreme heat. So we engaged with over 200 people for the research, including via interviews, focus groups, roundtable and a couple of workshops. And the participants range from local and national government, first responders, so the ambulance service, the fire brigade, the private and third sectors and adaptation practitioners. And we've also had widespread input from a range of different organisations into the work. And what did we find? Well, we found that overall it was felt that England's resources were severely stretched during the 2022 heat waves, with a range of stakeholders across the different groups that I just described, saying that they were struggling to keep on track of some of their tasks during the response. Participants largely felt that preparedness was not sufficient to match the scale of the issue, and there were reports of stakeholders such as local authorities being taken by surprise, slow decision-making and avoidable impacts. London participants stated that resources were extremely stretched. In particular, you may remember we had a number of wildfires and the London Fire Brigade called it their busiest day, this was the 19th of July, since World War II. So there was considerations that there was limited capacity to adequately respond during the heat wave, particularly given the challenge of multiple stressors, including a large number of fires in the Greater London region, transport disruption and significant impacts to health and well-being. The participants we spoke to in Manchester reflected that the heat wave was unprecedented in the northwest as well. It wasn't just in London, it really was across the country, which was making a number of decision makers admit that it had taken them by surprise. And some felt that there was a lack of preparedness and urgency to deal with the heat, a lot of working in silos, so organisations not working together, a lack of joining up, and a lot of disjointed processes and responses. And when it came to participants from the Yorkshire and Humber region, they saw that public services had been placed under considerable pressure during the heat waves, and participants did speak about the lack of resources, suffering from crisis fatigue. They were still exhausted and depleted from the COVID crisis, and alongside other pressures to deliver. So they did mention that the real need for public campaigns to increase education and preparedness about heat risks to help overcome some of the behaviours that were experienced. And now moving on to the different groups of individuals that we spoke to. So as a reminder, we spoke to first responders, which included the ambulance service and the fire brigade, national government and local authorities, communities and civil organisations, and then water and utility providers. So fire responders commented on how operational and strategic on-the-ground resources to respond to the heat were seriously stretched, and with the ambulance and fire services particularly talking about being under pressure and giving very particular examples around, say for example, their uniforms not being adequate for the weather. So these participants felt that there was an overall lack of preparedness, which led to a number of avoidable impacts and further compounded by inadequate resources, funding and capacity, particularly given the severity of the event. Those participants from national government departments and local authorities felt that heat preparedness and strategies were inadequate to deal with the extreme heat, and the responses were very limited. Several issues relating to heat governance were raised, including a lack of prioritisation of heat risk both seasonally, so both in the summer and all year round. So whilst we're specifically focusing on the heat waves during the summer, we know that heat in general is a problem for the UK. We don't need 40-degree heat for people to start having effects from the heat. So some government departments and local authorities did manage to deploy some of their resources to members of the public, and in some cases they did mention utilising past networks that had been set up as a result of the COVID pandemic. When we spoke to communities and civil society organisations, again, they felt the UK is not yet prepared for these types of risks, particularly if we're going to experience more of these events such as the one in 2022. Important to bear in mind that the 40-degree heat was just over one day, so any prolonged events of that nature would have serious consequences. And what was particularly highlighted with that group was the multiple and the cascading nature of the heat risk, which meant that some of the networks that they're working with were severely stretched. And then finally, we spoke to water and utilities companies, and they provided a mixed set of views around how well prepared the UK was. Some of them did highlight the fact that they had very strategic risk plans in place to deal with these types of external stresses, but that the additional compounding and cascading risks, such as drought, which the country was in a drought at the time, a lack of public perceptions and awareness of dangerous behaviours. For example, they had a few cases of trespassing and people swimming in their reservoirs, which is increased risk to life. Really emphasise the need for better communication. So with that in mind, what are some of the priorities that are needed when thinking about responses and resilience and preparedness to heat? Well, climate change mitigation is obviously needed to address the root causes of climate change and prevent more frequent and severe heat events. So we do really need to focus on mitigation. We need an improved climate change adaptation strategy to protect public health, infrastructure and ecosystems from the immediate impacts of extreme heat events. And this really needs to appropriately consider and address the cascading and compounding impacts of heat risks. We need that policy leadership and ownership and responsibility. This doesn't really seem to be widespread in the UK, so it needs to be a priority. We need a central government department which should take responsibility on this, working closely with other government departments with a very core strategy and process in place. So we need this coordinated systems-based approach to align and integrate both climate adaptation and mitigation priorities. Whilst the priority very much is on heat risk, and it should be in the same way it has been for other climate risks, it does need to consider the implications for mitigation. So for example, we don't want to be finding ways that are going to increase energy use by encouraging the use of cooling technology such as air conditioning. We need to look at this as a whole systems approach. And to do that, we need to bring together stakeholders and members from across the public, private and third sectors. There needs to be stronger regulation, planning policy and benchmarks for all sectors to address the wide-ranging complex variables that do exacerbate the impacts of heat risk and to have appropriate incentives in place. So for example, there is no statutory maximum workplace temperature in the UK, and a certification scheme that clearly shows the overheating and cooling profiles of buildings would be an asset in the same way as we have our energy performance certificates. As I mentioned earlier, the building stock in the UK is one of the most inefficient in Europe, so that needs to be revisited and retrofitted to reduce overheating. There's quite a large body of evidence on this. We need to be building local, organisational, individual and household level resilience, so not just at the high level governance, with really a focus on improved awareness and understanding of heat risk among the public, and increased awareness of vulnerability, as we do know from survey research that people who are vulnerable, say people over the age of 65, don't always self-identify as being vulnerable. And we need to be protecting the most vulnerable from heat risks, so we need to identify and maintain a register of at-risk groups across society, including broader categories such as outdoor workers and those who might be more exposed to those extreme temperatures, and understand how these vulnerable groups are affected by and respond to the heat.
Okay, I think we might have a slight technical problem here, but I think we have heard quite a really great presentation from Candice on this. I wonder if we click on to the next slide, we'll hear a conclusion, but if not, I think we can wrap
for your
this up.
time.
Yeah.
I hope you enjoyed the rest of the conference, and please do get in touch. That's my email address there if you have any questions. Many thanks.
Awesome. I think that was a really interesting presentation looking into the heat effects and kind of building this culture of heat. Yeah, and Brian Golding also kind of gave some thoughts. Yeah, the results are really the results are much more pessimistic than those in the public surveys into the response of the warning. And maybe Brian, you can just give us a quick thought of this comment, then to hear your thoughts on this. If you can unmute yourself, Brian. Yeah.
I'll try. I haven't got the data actually with me, but I know I think over 90% of people who were surveyed.
Sorry, Brian. I think you might have
after the event. So this is an independent survey that is carried out on behalf of the Met Office to see how effective the warnings are. and over 90% responded saying actions were. Of course, this is another matter, but we do know what some of them were. So over 60% commented that they were took extra hydration, which of course is one of the key responses that people can take. So that seemed to be very positive, different from the message that was coming from Candice. So yeah, it's something we need to look at.
Thanks, Brian. And it's good to point out those differences and try to see what's kind of the underlying reasons between those differences. And yeah, we'll definitely pass that on to Candice on, and try to unpick a little bit. Maybe we can hear back from her on why there's difference between some of those surveys. Yeah. Thanks, Brian. All right, so on to the next presentation. It's from Brian Mills from University of Waterloo, Canada. And we're changing tack a little bit. We're looking to winter weather information. So please share.
Good day, everyone, and warm greetings from Waterloo, Ontario, Canada. My name is Brian Mills, and I'm a research scientist with Environment and Climate Change Canada, adjunct professor at the University of Waterloo, and a member of the World Meteorological Organization's High Impact Weather Project. My apologies for not being able to present this live, but believe me, a dry, scripted Brian is a much better option than sleepy, incoherent 3 a.m. Brian. Please do get in touch with me by email if you have any questions or comments concerning my presentation. Today I'll be talking about the influence of winter weather information on mobility decisions, behavior, and risk outcomes, primarily through the lens of the theory of planned behavior. Given my excessive pre-conference ambitions, I will only briefly mention social practice theory and alternative framing to study in follow-up work. Injuries from motor vehicle collisions and slips or falls are routine risks faced by all people on the move, whether for social, household, employment, or recreational pursuits. As this video of my future son-in-law and his new Tesla shows, these incidents occur every day in every city and in every season. They are much more prevalent, however, during inclement weather, in particular winter storm events involving some combination of snow, freezing rain, reduced visibility, and sub-zero temperatures. Colleagues at the University of Waterloo and I have initiated several studies in the past to investigate motor vehicle collision risks, but have rarely included fall-related injuries or focused on the role of weather warnings and other information on risk outcomes and behavior. In response, I developed a new research project whose main components are presented on the slide. I won't have time to review everything in depth, but instead will focus on the three elements highlighted in blue, red, and amber. Formal injury risk analysis on the left, exploratory interviews and experience sampling of a small purposive sample of households in the middle, and interpretation of results through the theory of planned behavior on the right. The study was focused on the regional municipality of Waterloo, Canada, located in the Great Lakes region of the province of Ontario, about 100 kilometers west of Toronto, as shown in the figure. Hourly government records covering the 2002 to 2017 period for weather, motor vehicle collisions, fall-related injuries, and other variables were analyzed to estimate the relative risk of injury during winter weather events. Each event was matched to a seasonal, dry, non-holiday, and non-weather alert control period of identical timing and duration selected 1 week before or 1 week after the storm. Here is an example event in the database. The chart in the lower left tracks cumulative hourly motor vehicle collisions with concurrent half-hourly radar imagery. The weather conditions at the regional airport are summarized in the weather station model graphic with any warnings flashed immediately above. The red portion of the chart bars represents the number of collisions in the corresponding control periods. In other words, incidents and injuries that statistically would have likely occurred in the absence of impaired weather. As the relative risk estimates and confidence intervals at the 95% level suggest, winter storms were associated with an 18 to 58% increase in motor vehicle collision injuries and a 38 to 87% increase in fall-related injuries relative to dry, otherwise comparable conditions. Other findings from this work showed that there was considerable evidence of variation over time, interannually, seasonally, and between and within storm scales. There was no statistically significant difference in relative risk between warned and unwarned events, and overall, the work was suggestive and helpful in shaping questions and hypotheses about dynamic vulnerability, exposure, behavior, and outcomes, but really insufficient for deeper understanding. What this means is it calls for different frameworks, new methods, and primary data. In response to the risk analysis, The second study element involved a much different approach, this time centered around a small purposive sample of 12 households selected to target those with younger children making frequent discretionary and non-discretionary trips. Selection criteria are indicated on the slide. Semi-structured interviews were conducted just ahead of the 2018-19 winter season, in which we applied experience sampling. The recorded interviews were about 60 to 90 minutes long and divided into 3 stages. 1, a basic documentation of socio-demographic characteristics. 2, a household scheduling activity. And most importantly, 3, a final section designed to reveal participants' perceptions of winter storm-related travel risk, activity and trip practices, intentions and behaviors, and the use of weather-related information and knowledge in making decisions and taking actions. Participant dialogue during the final interview stage was transcribed and thematically coded to empirical factors thought to influence behavior from the literature. For example, response choice and efficacy, weather-related information sources and use, hazard perceptions, and perceived concern, as well as individual constructs within the theory of planned behavior. Questions probing the same empirical factors and theory of planned behavior constructs were also included in the instrument applied in experience sampling the same cohort of participants across 3 winter storms, the first approximately 2 months following the last interview. I will only be discussing theory of planned behavior aspects in today's talk. The graph depicts one of the winter storm event timelines, noting the presence of alerts, right here, basic meteorological conditions, here and here, and at the very top, the period of time when participants first received and completed each of the 4 mobile surveys. Now let's turn our attention to the theory of planned behavior, or TPB for short. The TPB is one of several social cognitive models that attempt to understand what motivates the deliberate and volitional choices and actions of individuals. The original developers, Eisen and Fishbein, estimate that the model has been applied in over 4,000 applications to date to explain and predict behavior and inform behavioral interventions, mostly in areas such as health, environmental and consumer behavior, and transportation. To my knowledge, only a few studies have explicitly examined weather information. In the model, attitudinal beliefs about the expected efficacy and experience of performing a particular behavior, here, beliefs about what important family, friends, or colleagues think or would do, and beliefs about an individual's perceived internal and external control to perform the behavior are strongly and positively associated with intentions, which are the primary precursor to actual behavior. The intention-behavior relationship is modified by actual limits on behavior, represented here by the dotted line at the bottom. For example, limited resources or government policies. Other research have identified additional variables to include in the TPB, such as habit and anticipated regret, which we will consider later in our study. Given the small sample and experience sampling approach chosen for this research, we performed exploratory descriptive analysis on the primary data. This may be expanded to a more traditional large sample regression or structural equation analysis in future work. This project, however, was aimed at assessing viability of TPB at a very granular level. A first step was to literally see evidence of the theory of planned behavior constructs in our interview deliberations, and we did, as supported by the examples in the table for a variety of risk-reducing behaviors. Take, for instance, the entries coded to injunctive subjective norm, the importance of what I think significant others believe I should do during a winter storm situation, in this case, trip or activity cancellation or deferral, and descriptive subjective norm, what I expect significant others to actually do themselves in the same situation. The 2 most commonly identified risk-reducing behaviors in the interviews, cancellation or deferral of trips and activities, and departing earlier, were selected as the subject TPB behaviors in the experience sampling questionnaire instrument. Participants were asked during the second survey, following issuance of official warnings by Environment and Climate Change Canada, to rate the strength of their intent to perform the behaviors. They were also asked to answer a series of questions designed to evaluate experiential and instrumental aspects of attitude, injunctive and descriptive components of subjective norm, autonomy and capacity elements of perceived behavioral control, and anticipated regret. Reported actual behavior was measured in subsequent surveys taken at the peak of the storm and again after conditions improved. Consistent with Fishbein and Eisen, questions were structured as in standard TPB studies, and ratings were assigned using a series of 7-point semantic differential scales, each with bipolar adjectives. The figure shows survey responses for participant P11 during the second sampled winter storm. Here we see on the left very negatively rated attitude components to both the expected outcome and experience associated with canceling or deferring a trip during the storm, negative injunctive and neutral descriptive subjective norm ratings, and minimal perceived freedom or capacity to perform the behavior. These, in addition to high levels of anticipated regret, are very consistent with a very low expressed intention of canceling or deferring the trip, and ultimately the participant's decision revealed later in the storm to not perform the behavior. After aggregating all of the valid data for each participant in STORM, an analysis was conducted to assess the consistency of individual constructs and their subcomponents with intentions and behavior. Strong or weak attitudes, subjective norm, and perceived behavioral ratings were deemed consistent if they corresponded with equivalently strong or weak ratings of intention and behavior respectively. Bold values indicate where 2/3 or more of the matched data pairs were consistent, inconsistent, or neutral. For the canceling deferral behavior, we observed that attitude, perceived behavioral control, and anticipated regret show the greatest consistency with intentions and or behavior, which appears very much in line with correlations reported in TPB studies using considerably larger samples and more sophisticated statistics. In the previous slide, intention was observed to be moderately consistent with reported cancellation or deferral of trip activity behavior, and very inconsistent with behavior that required participants to depart earlier. While the full set of constructs was measured for just these two stated behaviors, consistency between intentions and reported behavior was assessed for a much broader range of responses. For example, in the table below, by simple inspection, there appeared to be weak association between intentions to telework and actually working from home, but this varied considerably by participant and by winter storm. Such variability, revealed primarily because of the experience sampling strategy adopted, makes one question how valid ratings are from traditional TPB studies, especially those that rely on single cross-sectional surveys dependent upon hypothetical situations or general recall of individual experiences dislocated many weeks, months, or even years from actual risk events. Another concern revealed through the study relates to how we define actual behavior and what it represents relative to reduction in risks. Does a person need to perform a particular behavior consistently over multiple occasions, or is one instance sufficient? Whether this is drawn from distant memory in traditional TPB applications, or reported in near real time over the course of a winter storm, as in this study. As noted on the slide from example excerpts from open text questions in the experience sampling surveys, when participants adopted a risk mitigating action early in the storm, subsequent responses often introduce new or additional types of exposure or vulnerability. Does this undermine the benefits of one instance of performing the risk-reducing behavior? I'm not sure. These concerns aside, and even if consistency is evident and the theory of planned behavior holds up well, how can we use it to inform the provision of weather warnings and related risk and recommended response information? Let's explore this further by reviewing the behavioral recommendation content from a winter storm warning issued by my agency, Environment and Climate Change Canada, emphasizing the postponement of non-essential travel. After examining the warning content, the primary influence is via instrumental attitude, through the provision of a rational account and expectation of the storm hazards, their potential impact, and recommended actions people can take to reduce risk. Arguably, this is where improved forecast accuracy, precision, and timing, and the advancement of impact-based or impact-oriented warnings will have the greatest potential effects. It is much less obvious how alert information might activate or strengthen ratings for the other components of the theory of planned behavior. Interventions focused on these constructs might concurrently be seen as outside of current service agency mandates and protocols. Yet these other constructs, in particular perceived behavioral control and anticipated regret, might be equally or more important than instrumental attitude. After this admittedly whirlwind tour, in summary, here are key findings from the consistency analysis of TPB constructs across two common response behaviors, a critique of the theory of planned behavior and identification of potential issues or limitations, and interpretation of a typical winter storm warning through an idealized theory of planned behavior lens. More generally, though, beyond these findings, I hope that researchers in this community see the value in engaging with social theories like TPB that are applied to many other facets of life and society. I also hope that people see the relevance of drilling down into granular and nuanced features of risk by using small samples and experience sampling techniques that permit observation as actual risk events, warning processes, decision-making, and behavior unfold in real time. Future research will involve further investigation of TPB and other theories such as social practice theory. More relational and interpretive, theories of social practice challenge the framing of winter mobility risk from the strict perspective of individual attitudes, behaviors, and choices, and may be better able to explain changes in risk over seasonal, decadal, and longer time frames. In closing, I want to thank you again for listening so patiently. A reminder that while I'm currently asleep, please feel free to send an email if you have any questions or wish to discuss any of the material I've presented. A list of references to the work I've described or cited will be available in the final PDF of slides provided to the organizers. Take care and thank you.
A really interesting presentation from Brian. So I think we need all to have a bit of a break after sitting down from the screen. So I think in the interest of time, if people can come back in 5 minutes, it's just to stretch your legs, grab a cup of tea, coffee, and we can continue on to the next session. And feel free to keep putting your questions in the chat box for Brian, if any. So in 5 minutes time, we'll all see you back here. Thank you. Okay, welcome back, everyone. Hopefully everyone has stretched their legs and grab a cup of tea. I'll pass on the next session, the second half of the session to Jelmer as to host and facilitate the session.
Yes, thank you very much, Marion, and also for hosting the first part of our session. Hello, everyone. My name is Jelmer Jeuring from the Norwegian Meteorological Institute, and I continue with the second part of this session, Preparedness to Respond. And we have 4 more exciting presentations for you in this part. And the first one is a recorded presentation based on similar issues with time zone differences as Brian in the previous session. So this presentation is by Justin Sharpe from the USA. He is affiliated with CIWRO, and he will be presenting on engaging, communicating, and training a holistic approach to addressing equity in weather warnings. So I will share my screen with the presentation, and please enjoy.
Good morning and welcome to my talk. My name is Dr. Justin Sharpe. I work for the University of Oklahoma PREVENIR Institute for Severe and High Impact Weather Research and Operations. I'm the Vortex Southeast Social Science Lead, which is a tornado project. My presentation is Engaging Communication and Training, a holistic approach to addressing equity in weather warning. So let's get into it. I just want to explain that less than 1% of all tornadoes are studied, which is kind of important. We need to know how people react to weather watches and warnings that are given to them, and the extent to which they can act, or the extent to which social vulnerabilities impede their ability to act as well. I often use comic strips for communication, both with the public and other means as well. So this is why my presentation is like this. One thing we do know is that mobile manufactured homes are extremely dangerous for people who experience tornadoes, and more than 50% of people are killed in mobile manufactured homes when tornadoes occur. And this is some research that I did a couple of years back, actually trying to understand that a little bit more. We also have understandings from other researchers as well. So people that have talked about how nocturnal tornadoes can be more deadly, how people get less information. We've also got information from the communication sphere as well that is telling us about, you know, how people not just receive the information, but what they do with it and how they check with people around them, and even virtually as well, to ensure that, oh, this is a serious event that I need to act to right now. So we'll get into that a little bit as well. The role of social vulnerability has been well described by many other authors. But the idea that your financial security, gender, ethnicity, housing type, disability, you know, really do impede some people from being able to take the best actions that we would wish for them, or they are in structures that are just not safe enough. And so they probably need to go somewhere else. But the question is where and how are they getting there? Not always an easy question to answer. Just for a little bit more context, more than 1,000 tornadoes occur every single year in the United States. And this impacts 44,000 households and about 111,000 people. We cannot go to every single one of those. However, what we can do is be smart and use technology to help us find out a bit more information. And so we developed an app called Tornado Tales, which asks people where they were, what sort of structures, were they at work, were they at home, were they at school, did they feel safe, did they get a tornado watch, and how did they get that watch, did they get a tornado warning and how they got that warning, but then also allowing them to tell us verbatim their stories. We tested this in the field, and this is out in Mayfield and Kentucky, again using a comic strip to communicate this here. What's important to go alongside that, though, is to have buy-in from NOAA and SSL and the Weather Service, so that this is given out as press releases. That allowed me to go on national TV and explain this, but also in more smaller local media markets when tornadoes occur. It's really important. And this was incredibly important for a tornado that hit near Kansas City a couple of years back. And we had a press release. We got 90 reports in 20 minutes because of that. And so that gave us a really good understanding of what people were experiencing. And it also showed us where people were inside and outside of the tornado warning polygon at the time as well. So that was really interesting for us. You can see this story map and other information about it, and about looking at nocturnal tornadoes generally at this QR code or at the bit.ly link there as well. My presentation has been uploaded as well as this, so you should be able to have access to that at another time. So I'm going to move on now, so apologies if you don't get the bit.ly, it is at the end. So we also go out and we do things in the field. And so we've been out to Mayfield, Kentucky and the Quad State tornado. We've been out to Idabel and southeast Oklahoma and northeastern Texas. And we've also been out more recently to Rolling Fork, Mississippi. And each tornado tells a different story, and the watches and warnings that people were receiving and how they acted upon those is really, really important. And this image shows a search building in Rolling Fork following the tornado. So this is one of the things that we did. We did a transect along this tornado outbreak there, going along towns that had impacted over the time and actually speaking to these different groups, the public, Spanish-speaking and immigrant populations, and emergency management. And we did that specifically because we're trying to understand, generalizable information, but also sometimes specialist populations or populations that are underrepresented or don't get the information necessarily in their language. There's no point having a watch or warning go out if it doesn't go out in the language. And I know that's improving, but there's something to be thinking about here. There's a difference between data and the context that, say, interviews bring as well. So you can actually look at percentages and actually do statistical analysis on them. That's very useful, but sometimes we need the stories as well. And that's what the tornado tales and going out in the field does as well. And then the third tranche of what we've been trying to do is this Vortex, Southeast and Mississippi Alabama Sea Grant collaboration. And we've created this model of dialogue, and we wanting to return our research to the communities rather than just parachuting in, doing extractive research and then never hearing from us again. So actually coming up, we're going into Rolling Fork. I say we're going in, we've been invited into Rolling Fork to actually disseminate what we found from our interviews as well as doing some other activities on preparedness. So this is a very useful thing that we've been doing. And this is an example of the communication tools that we use as well. This was on a lenticular magnet, fridge magnet that goes on the fridge so that people don't just kind of get the information and it ends up in a stack of pizza menus. We use a theory of change model for this, and the idea is that it's kind of more of a bottom-up approach, and the idea is we're trying to engage our communities, equip them with the right things, and then empower them to make changes to actually improve on their resilience outcomes over time. I'm sorry that this diagram has a lot of information on it. You might want to go back and look at it, but I'm going to actually unpick what that means now. It gives you some examples. So one of the things that we've been doing is a lot of outreach and engagement. We're doing this in libraries. Libraries are really good because they're on bus routes, because they're buildings that people know and trust and people go to, and we're either heated or cooled depending on the time of the year. So it's quite a nice way of engaging people in. But we've done other projects as well, all over Mississippi and moving into Alabama now as well. And the Selma anniversary I'm going to talk about in a minute, and then the comic strip I'll also talk about in a minute. So this is one of the comic strips that it's just one frame from a comic strip that we used with 150 elementary school children when they'd been impacted by tornadoes recently as well. And one of the things we've got here, if you've got sharp eyes, you might notice that one of them's in Spanish. I purposely kind of created a narrative in which we could actually have Spanish in there, and then the English translation is in the yellow box underneath, because that's important to help those groups understand what we need to do, and also understand that not all families are exactly as people think, that 2.4 kids sort of thing. So this engaging, equipping, empowering that you saw on that big diagram, well, this is what it means in practice. We find those locations, make sure they feel safe there, and then the skill building. And the skill building doesn't necessarily come from us. It comes from the Red Cross. It comes from local fire departments, you know, how to use a chainsaw safely. This is hands-only CPR as well. And then in practice, it gives people much better self-efficacy beliefs. And I think that that's something that's been missing. And so this is one of the things that we've been trying to do. Here's just a map. We've now visited, I think, something like, it says 20 plus, I think we're up to 25 libraries visited. And what we're trying to do now is move to a train the trainer. Those librarians all have professional networks. Can we get train the trainer model there so that we can train them en masse and then give them the tools to go out and do these in these communities? So this is what we're trying to do now, is that move towards longevity and sustainability. That's really, really important. So, you know, can we offer them a professional skill set here that actually goes as part of their, you know, performance reviews that goes over the years? How do we get those kits into those libraries so they can always use them and keep repeatedly using them as well? And also, you know, maybe we can transition some of this online so they've got those tools that they can download at other points. This was not something that we did overnight. We started off with a pilot project in 2021. We did more training in 2022, and we actually started to work out a 6-hour curriculum. We also have a 2-hour curriculum now as well. And then we've worked with FEMA Region 4 in our region, and we've hosted a lot of collaborations where we can communicate, you know, things about that public complacency is you know, not as important as the social vulnerabilities. And then finally, this tornado event in Selma, Alabama, we collaborated with multiple locally based stakeholders to co-produce this event to help heal and learn how to increase self-efficacy and response efficacy throughout. And so this is the event. This is me there explaining to people and checking their phones. One of the things they had to do is visit 8 stations. Once they'd visited all 8 stations, they got a little stamp. When they got all 8 stamps, they took that to the front, and we gave away NOAA weather radios, and so we had to raise money and funds for those things to actually buy those at cost as well. So this was a very, you know, a good event. And so what we do then is, and what we're trying to show with this model, is assess what the community leads are, bring in the local partners and resources. So it's not about us or government agencies or academics doing things. It's about how can we help you to do this and accomplish these things. And it means working with local emergency management, working with local fire department, working with the local mayor, sometimes working with Chamber of Commerce, working with the people who are embedded already in those communities but want to see change in those communities. Perhaps they don't have the resources. So we're trying to find a way of bringing these resources to them. And I think that this is what this shows. And you can see how busy this particular event was as well. We more than 300 people attended this, and we also had buy-in as well from local politicians as well. So what we did afterwards, we reflected on this, you know, what we needed to do. The skill building activities led by local organisations was key. The Red Cross, the hospitals, the fire department, showing people how to use chainsaws, and they did that outside. We did have good weather for this as well. We co-hosted with an arts centre as well, because they were unveiling a mosaic which was showing healing. People brought in smashed bits of crockery and glass, and then they smashed it up further to help create this mosaic, which was unveiled, and I will show you this in a second, on the day. And this is in, you know, Selma, Alabama, it is, you know, a not particularly well-resourced area. So this is a really important part of the healing process as well. And so you can see the other things there as well. At the timing to coincide with the past disaster helped raise awareness. It was the year anniversary, and so people were dialed into that. And we had a lot of local media buy-in as well. But we also had boots on the ground putting flyers out there as well. And again, that's what you need to do. You need to be present. You need to build those bonding and bridging social ties. Building that social capital, I think, is key to what we've been trying to do. This is the mosaic there, and I love this photograph because it shows on the left-hand side the Edmund Pettus Bridge, which is famous from the civil rights movement, kind of crumbling down, you know, that being the impact of the tornado, but then strength, resilience, and the butterfly rising out from behind there at the end. So with that, I'd like to thank you very much for allowing me to talk with you today. I'm bang on 12 minutes. Any questions I'm going to say, please can put them in the chat, or maybe have them emailed to me because it'll be 3 in the morning by the time this goes out. Thank you very much.
Yes, so thank you on behalf of everyone, Justin, for this presentation. And as he said himself, please feel free to put any questions in the chat. I want to apologize for the slight out of sync slides with the voice of Justin. This was a video file, so there was not much that we could do there. But I think we all got the great message that how to build capacity, both to prepare and to respond, but also to recover from disasters on the local community level. So let's continue then with the next presentation. This will be by Rob de Hond, and he will be talking about the work from Doctors Without Borders, I think particularly in South Sudan. So Rob, if you are ready to share your slides, please go ahead.
Yeah, hello everybody. So yeah, my name is Rob de Hond. I work for Doctors Without Borders, or MSF, medical humanitarian organization. So thanks a lot for inviting me to this conference. So I'll present a study that we conducted on 2 large-scale study events that happened in Pibor, eastern South Sudan, and where we analyzed how MSF flood risk management process went along these 2 consecutive disasters. So within MSF, we try to conduct research to build our understanding of how to operationalize actually climate adaptation, forecasting, anticipatory action in our preparedness and responses. Conducting research in emergencies or post-emergencies is not always straightforward or easy, so that can limit what we can do often. So what we need here and what is in line with global trends. So in many of the areas where we operate, we've seen an increase in the intensity and frequency of floods. And it's also very often aspects of climate vulnerability there, or they come together with also aspects of current conflicts, displacement, food insecurity, and general poverty. So really these compounded crises where people it becomes more and more difficult to recover from them and to prepare for the next flood when it happens. And so it also complicates interventions in those areas. In terms of the health impacts of floods, the direct health impacts of floods that we see, they change over time, where at the start, the main health impacts are direct drowning or trauma. And then we've moved on more to just gastrointestinal infections, cutaneous and respiratory infections. And then later on, we see upsurge in malaria. And really the often very challenging one are the indirect ones. So floods causing population displacement, damaging infrastructure, roads, health facilities, water and sanitation facilities, and so leading to water pollution, livelihood destruction, being crops or cattle, and so really creating a very complex context for intervening effectively, especially if you come late. And so because of this growing and compounded needs, there has been since a while a search for authorities and humanitarian actors to rethink how we manage disasters. So to be better prepared and to integrate into preparedness, forecasting, early warning, and anticipatory actions. And for that to strengthen the general response. And also to consider post-flood, that the disaster doesn't stop, but and building back better, if possible, of infrastructure or programming. So there is this commitment, and there's quite a question of how can this be operationalized? How can this be done in practice? What does this mean? And so that's why we're trying to learn lessons from our interventions and activities. So that's where the study comes in. So this is a map of Pibor in Eastern South Sudan. So in 2019 and 2020, 2 large-scale floods occurred there, which each time more than 100,000 people that were affected and displaced in the area. And it is a classic compounded crisis as well. The area before the floods was experiencing regular violence, already very high rates of malnutrition, poor access to healthcare generally, and water and sanitation facilities. And so as we were supporting 3 health facilities in that area. Also particular to the area is the population. It's a pastoralist population, so they have seasonal movement with the cattle around the area. So along where the green pastures are, they move along with their cattle. So population movements, especially throughout the rainy season, is also a big factor to consider. Well, this is just an impression of 2019, what the area looked like. So for conducting the study, when we used a quantitative approach, we went into document review of both interventions from the left side, what actions were taken, and we conducted interviews with staff that was involved in the responses. And so we collected data on two axes, one being a temporal axis, so linked to the phases in disaster management cycle, where we documented what was done in terms of preparedness, so for safeguarding operational readiness, what was on linked to flood risk monitoring. Was there a local warning used to act early on floods that was bound to happen? And if so, which anticipatory actions were put in place? Was it linked to safeguarding our own operational capacity, or were there also proactive responses toward the affected population already put in place? Then during the actual response, we assessed how impact assessment was done and which other actions to reducing health impacts were put in place. And in terms of recovery, similarly, what was done in the recovery phase in terms of service rehabilitation and still reducing health impacts in that post-flood phase. So that's a temporal axis that we investigated. And we also looked at the more operational axis, or operational domains that were covered during those interventions. So linked to flood risk understanding, healthcare delivery or provision, water and sanitation, support to displacement through fights or non-food items, for example, nutrition, and then community aspects, so we call this, and collaboration with other with local authorities, local stakeholders, and international stakeholders. So what our results showed that in the 2019 flood, we had a regular project running in the area, and the staff actually reported very low alertness for floods, and also unfamiliarity with forecasting tools. So the teams were not prepared, and they were actually surprised when the flood occurred. And this flood destroyed the health facility we were supporting, and also the pharmacy. Because of that, also the team got evacuated and external support was requested. So this all led to loss of operationality and resulted in a 1 to 4 week response gap, depending on the type of activities being put in place. So quite a delay. During the flood as well, teams had to rely on quite costly aerial assessments. And healthcare that was delivered was mainly facility-based, so quite limited as well in a geographical area. After the flood, the team focused mostly on facility reconstruction, but unfortunately then there was a period of violence that occurred in the post-flood period, so we had to evacuate from the area again. However, we came back the year after in 2020, and there from the start, with a standard emergency intervention period to respond to population displacement and malnutrition. But from the start, their teams, they reported really following rainfall forecasts. They were also conducting local river level observations, and they reported really an operational readiness to shift to a flood response whenever this would occur. So they were also using a local warning of a certain facility that they had seen flooded in the previous year, and that they used as a warning to shift to anticipatory actions. So at that moment, relief items and boats were pre-positioned into the area, so to avoid that transport would be hampered. And to safeguard operationality throughout the response. And also early healthcare interventions were launched by mobile clinics, and also water distribution was set up in different locations early on. So also based on understanding of which areas would likely remain dry. So because of this, the response actually improved importantly. So there were 5 mobile clinics around the area, so much more mobile and the geographic response in terms of healthcare delivery. And this actually resulted in the doubling of the number of consultations conducted and the doubling of the volume of water provided throughout the response. support and improve response generally. Also in recovery phase, the teams shifted to borehole repairs, so that people, when they moved back to their areas, had still access to safe. So, so all these shifts in practices, that were reported were clearly a shift in the eagerness to monitor forecasting data and couple that with local observational data of flood risks, and use that as triggers for action. So what remains, what is still a question mark there, is okay, how does this technical forecast translate in reality? So what can be like actual thresholds of these technical alerts to move to action? And how does this, we call it data brokerage, it's quite technical information that is out there that's not always easy to understand or to use by field teams. So how is that, information movement and analysis worked for teams to actually be able to act upon it? What was also shown that there's a clear added value of readiness and anticipatory action. Quite obvious, but it's good to demonstrate it. And questions there remain that there is a risk of acting in vain, obviously. If you put in place actions in anticipation and the flood is less heavy than expected, that is a factor to consider because it also comes with a cost. And anticipatory action also requires flexibility in funding, which for MSF we have for independent funding. It's more easy than for certain other humanitarian actors or often also authorities. So the aspect of mobility throughout a flood response is really key for assessments and for primary healthcare delivery. But mobility is also one of the things that is first hampered during a flood. So to be factored in. And there's also an aspect of level of care that can be provided. You cannot provide the same level of care in a mobile clinic, in a tent on a retreat somewhere on an isolated island versus in a healthcare facility. So that's kind of compensation to be made and to be discussed on. So even more important, I would say, than these shifts in practices, were really shifts in mindset that were reported by the teams. So really a shift in mindset on integrated from the start a good lens on any of the planning and responses that were put in place in the area, real eagerness for accessing flood risk information, and a willingness to act early. And also willingness to collaborate. That was one of our team members stated, as soon as the flood occurs, you are stuck with everybody that is in that area, so you have to collaborate with everybody. The main question remains from the studies was consecutive floods, so the team had a year to prepare, let's say, and then really it was built on experience from the previous year. Now the question remains, how can we shift it from an experience-based mindset to a default mindset, that in any flood risk area, from the start, there is eagerness to access information, there's willingness to act early, and so they're documenting this kind of experiences is really crucial. Another big factor that came out of the study was that we need to expand our community understanding. Again, to move from technical flood or hazard risks and integrate in their local vulnerabilities, coping mechanisms based on health status. But also exposure data. It's said with the local population, they're customers, so they move around, especially during the rain season. And so those population and cattle movements really impact the exposure of people to this flood risk. So, and teams reported that they were not aware enough of those. And so this also hampered the proper assessment. Well, that's what we took out of this is really to further mainstream and contextualize hazard monitoring, and to translate this into a language that is understandable for field teams, and to further operationalize also anticipatory actions, to really integrate this into emergency preparedness documents, plans, and so on. And also questioning if when we are present in an area, we receive the information of food risk. How do we communicate this to local stakeholders, to the local population, and so on? It's something that we currently are not doing. So really, this connection with communities and local stakeholders to be much increased, also in for extreme weather events and disasters. And then I said to continue documenting such experiences is really crucial. For MSF internally, we're quite a big organization, and everybody is necessarily as convinced or this well, not convinced is a strange word, but well, you need to properly argument why it shifts in our operations or in our practices and shifts in mindset. So I hope I stayed within the time and was clear enough. So please here you find my contacts from MSF Don't and an email address. If any questions, please feel free to reach out. Thank you.
Thank you very much, Rob, for this very interesting presentation. I think the sound was not always perfect, but we certainly got most of what you were saying, and the great slides really helped a lot as well. So I think we have time for one or two short questions. And one question from Everisto in the chat is about local knowledge and how local knowledge is incorporated in understanding and forecasting of floods in South Sudan.
Yeah, that's a very good question and a crucial one. In the years past 2020, the team in Pibor have been working much more on that to really understand, as said, this seasonal population movements as it comes with the rainy seasons, to understand where are people moving to, and to understand from local memory, let's say, if those areas are at flood risk or not. And also to understand people will continue moving if their livelihoods. They go with their cattle, so it's not a factor that will change. Just more to understand what kind of support can be given, for example, in anticipation, before the rains come, and distribute items that allow people, when they're out in the bush and isolated during a flood, for example, to treat water locally, to protect themselves from mosquitoes, so have mosquito nets available, and really adapt those kind of adapted support to what people will use most also during extreme weather events. But there's still a lot of work to be done on that. Yes.
Thank you. So there's a few more questions in the chat, but for the sake of time, I suggest we continue to the next presentation. But Rob, if you're still have time to hang around and answer the questions in the chat, that would of course be great. So thanks a lot. Now we move on to Julián Goñi. I hope I pronounce it correctly. And he'll be presenting about the PREVENIR project. So Julián, if you are ready to share your slides, please go ahead.
Good morning or evening, everyone. My name is Julián Goñi. I'm an anthropologist and I work as a specialist in disaster risk management in the Department of Meteorology and Society at the National Meteorological Service of Argentina. And on this occasion, we are going to present some of the progress achieved in the development of a flash flood early warning system within the framework of the PREVENIR Project that started in June 2022 and is ongoing until 2027. And well, PREVENIR is a joint research project between Japanese and Argentine institutions in cooperation with the Japan International Cooperation Agency and the Japan Science and Technology Agency within the framework of SATREP's program. And this project proposes interinstitutional and interdisciplinary collaboration between leading Japanese institutions in the development and operation of early warning systems, such as the Hurricane Center and the Japan Meteorology Agency, and Argentine institutions, such as the National Meteorological Service, the National Water Institute, and the National Council for Scientific and Technical Research. And the main goal of PREVENIR is to develop an early warning system for urban flash floods, designed for two highly vulnerable basins in Argentina. And to this end, the project includes the development of new technologies and strategies in 4 key areas. In monitoring, PREVENIR seeks the expansion of hydrometeorological observation networks and the implementation of real-time precipitation estimation methods using radar and satellite data. In forecast, the project proposes to produce flood forecasts with lead times between 24 and 36 hours by using numerical hydrometeorological simulations that will efficiently integrate available observations to improve their accuracy. In communication, PREVENIR aims to design effective communication channels with decision makers and the most vulnerable population based on the development of a web portal and the co-design of content for mobile telephony. And finally, in capacity building, PREVENIR proposes the training of human resources for the continuous improvement of the forecasting and the warning system. And also this is complemented with the continuous work with the community to increase the response capacity to the issuance of warnings. Well, with these objectives, 2 pilot basins were selected to develop the project in Argentina. The first one is the Suquía River Basin, which is a rural and urban basin in mountainous areas in the province of Córdoba, in the central region of the country. And the second one is the Sarandí-Santo Domingo Basin, which is a plain urban basin in the province of Buenos Aires. Both basins include 2 of the most populated cities in the country and were selected because of their demographic, geographic, and hydrometeorological features. And this system will be the first of its kind in Argentina and will provide useful tools and recommendations for the implementation of similar systems in other areas of the country, or maybe also the world. And the proposal represents a scientific technological challenge at the international level, as well as an interinstitutional challenge at the local level by working in collaboration with the local governments of 2 different provinces. And inspired by the idea of sustainable development that considers both social and environmental aspects, it is also an interdisciplinary challenge that seeks to combine scientific and technological developments from different disciplines with local knowledge to reduce risk. So here we have the 7 work packages in which the project is organized and the scheming of operation between them, so that the tools implemented allow reducing the impacts of flash floods. And next, in this presentation, we will focus now on the actions developed since 2022 in work packages 5 and 6. And well, about work package 5, it focuses on the dissemination of information and aims to develop, as I have mentioned, a web portal and a mobile application to enable timely and effective communication of forecasts and warnings to emergency managers, decision makers, and the general public. And as a first action of this work package, we developed preliminary workshops in which the project was introduced to the stakeholders working in risk management organization of both basins. And we collected data about their technical and operation capacities and their interest in the project. Then also with provincial and local disaster managers, agencies, flood scenario simulation workshops were held to analyze the use of the official information already available, analyze decision-making processes, and improve understanding of hydrometeorological hazards and their impacts. And finally, finally, about the testing workshops, we carried out the testing workshops with each of the agencies in their local offices. And the aim of this workshop is to test hydrometeorological tools, to learn how they are being used, and what advantages and disadvantages users find in each of them, because we want to consider this information to the design of the web portal. So these activities involve different government departments such as environment, social development, or water resources, among others. And as a result of these activities, we are now working on the co-design of the web portal, defining the monitoring and forecasting products to be included. The challenge here is to integrate all the information produced by the other work packages into a visualization that is easy to understand for users and easy to navigate on cell phones, even in areas where internet connectivity may be limited. And here is a proof of concept of what the interface would look like, in this case for expert users, which we are thinking will have different visualizations depending on each user and their training capacities. And well, about the work package 6, it focuses on working with vulnerable communities by approaching different stakeholders such as schools and civil society organizations to increase awareness and knowledge about urban flash floods. And in order to do that, are being installed automatic weather station and rain gauges in selected schools in both basins to develop citizen science initiatives. And we are developing educational activities with students about the risk of flash floods, their associated impacts, and recommended actions. And we have also developed, together with the government of the province of Buenos Aires, material with guidelines for teachers to address this subject with primary and secondary school students. Well, also meetings were held to present the project to teachers and school inspectors, and we continue to conduct workshops with residents of vulnerable areas to map together flood zones and share guidelines for accessing official hydrometeorological information for risk reduction. So, as a summary of the main results in this first year and a half of the project, through the activities of work packages 5 and 6, we have achieved involving local communities in the design of risk reduction strategies and promoting interaction between different stakeholders that sometimes don't have links with each other, such civil defenses with neighborhood associations or universities. Also, we have achieved the promotion of the participation of user and decision makers in all stages of the product co-design to ensure that the information is useful and can be easily understood and used by the community. And we continue to strengthen the capacities of vulnerable communities in terms of prevention, mitigation, preparedness, and response. And well, that's all. Thank you very much for your attention, and I remain open for any questions or comments.
Thank you so much, Julián, for a very interesting presentation. And I think there's a few questions in the chat. Please, if there's any more, feel free to write them there. I see there's one question from Marion. It's about the web portal and if the web portal is intended for use by public or just experts, and if including the public, did you see difference between perspectives between experts and public during the co-design process?
Yes, at the time we are testing, we are holding testing workshops with the experts of risk management agencies, and we consider their opinion about the needs of that web portal, and we, for example, the users of the risk management agencies said that if the web portal have a lot of data, it's too hard to navigate it in mountainous area where connectivity internet is low. So we had to select the forecast and products available in the web portal taking in care that thing, and maybe it could be a version of the web portal for less training users. We are thinking about a different interface for that.
At the moment, there's no other questions in the chat, but I think we can just keep going the discussion in the chat if there's any follow-up questions or more explanations. So for now, thanks a lot for your presentation and good luck with the project. If there are more results, we're looking forward to seeing them maybe in next year's or upcoming conference, of course. So thanks a lot, Julián. So then we continue with our next presentation by Tamara Janes, and she'll be presenting on action-oriented early warning services to support humanitarian decisions across timescales.
So thanks again for having me. Yeah, as I said, my name is Tammy Janes, and I'm a climate science advisor within the Foreign, Commonwealth and Development Office as part of UK government, currently on secondment from the UK Met Office. And in this talk, I'll be showcasing examples from within FCDO where weather and climate information has been tailored into co-produced services for humanitarian actors across different time horizons. So this is very much coming from the donor perspective, so might offer slightly different perspectives into some of the science. So I'm taking very much breadth approach here, but hopefully giving a bit of a flavor for some of the activities that are happening within FCDO. So I'll start off by outlining the context and the need for action-oriented services. I think everyone's probably all in agreement that there is a need for this, before diving into 3 separate examples of weather and climate support for humanitarian response in FCDO. I'll cover some of the common successes and challenges that we've faced in our work before finishing up with some next steps and plans for pulling through some groundbreaking research into these services downstream. So a little bit on the context first. So as I think everyone is really acutely aware, extreme weather events are increasing in frequency and intensity as the world faces the impact of human-induced climate change. Many of these events have the potential to lead to large-scale humanitarian crises, which historically have required a high level of response following the event themselves. But in recent years, humanitarian actors and actors more broadly are recognizing the need to take anticipatory action ahead of these extreme weather events, allowing for preparedness action to be taken and lives and livelihoods to be protected. However, there's a massive growing need for these action-oriented weather and climate information services that can support this move towards anticipatory action, specifically in response to weather and climate hazards. And our scientific research should really be needs-driven and action-focused. And the design of our research can also then be informed by the understanding of these user needs and the decision contexts that we're working in. So this is really a two-way process between our underpinning scientific research and enabling that action on the ground, and the learning from that action on the ground then feeding back into our underpinning research. Oh, I've frozen my slides. 1 second. There we go. Oh, I've gone too far, sorry. There we go. So I'll look at a few examples here of some tailored humanitarian support within FCDO. So I'm part of a scientific team that is embedded within FCDO, and we work closely with these humanitarian actors across weather, seasonal, and climate timescales to understand their priorities and co-explore ways of incorporating weather and climate science into their humanitarian response actions. So on short timescales, we've worked across multidisciplinary teams to co-develop a semi-operational service for advanced flood warning from tropical cyclones. So I'll go into a bit more detail on that in a bit. On seasonal timescales, we've collaborated with the UK Met Office to design and implement a monthly seasonal climate outlook service, providing 3-month and 6-month tercile forecasts to inform holistic assessments of emerging global humanitarian risk. And that's again helping to enable that anticipatory action on a monthly basis. And then beyond those seasonal timescales, we've worked closely with key teams within FCDO to raise awareness of the emerging El Niño event back in 2023. So it's an example that I'll go into a little bit more detail in terms of how we did that last year. So the first example I wanted to showcase with you today is the Flood Early Warning Pilot Project that's been commissioned through FCDO for a number of years now. So we're kind of a rolling pilot project, looking at how we can make this a little bit more operational going forward. But essentially, the purpose of this project was really recognizing that fluvial and coastal or storm surge flooding is one of the most devastating hazards, often featuring multi-hazard events, including strong winds and heavy rainfall. And the humanitarian impacts of these events are often very long-lasting. And when driven by intense tropical cyclones, that devastation can be even larger due to the corresponding catastrophic winds, loss of life, loss of livelihoods, and the spread of disease as well. So these are really a multi-hazard event that need preparedness action taken ahead of them. So within this project, we've worked across disciplines to combine fluvial and coastal analysis of risks into an informative and, importantly, timely bulletin to support humanitarian response within FCDO. So these bulletins, when triggered through FCDO, so we typically explore the need for that additional information ahead of time. They are typically completed within a day, so they're very quick turnaround product. And they provide expert analysis of meteorological conditions, so predominantly ECMWF, but also the regional specialised meteorological centres and the UK's Met Office. They include flood forecasting analysis, that's led by ECMWF and the Red Cross Red Crescent Climate Centre, coastal surge and tide modelling, led by HR Wallingford, and flood inundation modelling and population exposure, led by Fathom. And the end result is really a concise, digestible bulletin of a number of pages, usually about 5 to 10, that collates all of this scientific information into really tangible and actionable advice for humanitarian response within the high commissions in these countries. So to showcase a real-world example of where we've implemented this project quite a bit, unfortunately, the early warning pilot project was triggered a total of 7 times during the lifespan of Tropical Cyclone Freddie last year, which, as many of us will remember, was a system that traversed the southern Indian Ocean in February and March 2023, and it made multiple landfalls impacting Madagascar, Mozambique, and Malawi. It ended up, I think, being declared the longest-lived tropical cyclone on record, so this is an extreme event. But throughout this response, our technical team engaged iteratively with the FCDO humanitarian teams in post, so particularly in Mozambique and Madagascar and the Malawi country as well. And the bulletins that were created, each of these 7 iterations of the bulletins, were shared and well received with external humanitarian NGOs. So these trusted partners that FCDO have on the ground were able to ingest this information as well and feed that into their planning and preparedness response. This event also presented an opportunity for future learning and scientific research through identifying a need to better understand the discrepancy of what was observed in some of these countries versus what was forecast. So, for example, there was very intense flooding that was experienced in Malawi due to Tropical Cyclone Freddie. That was somewhat missed in our forecasts. And this is now being a focus point in one of our underpinning scientific research projects that FCDO has commissioned. If we look on seasonal timescales now, FCDO have also worked very closely with the UK Met Office to develop a seasonal climate outlook product. This is building off a similar product that was previously delivered into FCDO by the University of Reading. And this is now operationally produced by the Expert Weather Hub within the Met Office on a monthly basis and is distributed to cross-government mailing lists on the last day of every month through FCDO humanitarian networks. So these outlooks provide an overview of seasonal predictions, and they're based on the available Global Producing Center output that we have access to, so namely the WMO Multi-Model Ensemble, the C3S Copernicus Ensemble, but also individual models as well. So we obviously have the Met Office seasonal prediction system in here as well. And the timescales that these focus on are for a 1-month, 3-month, and 6-month lead time, each with varying levels of certainty, as we've seen previously in other talks, which needs to be carefully communicated with users. And they're focused on temperature and precipitation, so the outlooks provide information on the likelihood of an upcoming season being above or below normal. So these products themselves are used extensively within humanitarian teams in FCDO, to build seasonal preparedness and inform anticipatory action ahead of these slower onset events. So they're really good at flagging risks of emerging drought conditions or seasonal flooding conditions as well. And the main way these outlooks are integrated into humanitarian decision-making is through the Humanitarian Early Warning Note, or the HUN. This is produced by FCDO, and they are a central set of products that are aimed at raising awareness among senior civil servants of new emerging risks or likely deterioration over the medium term, so typically about 6 to 9 months ahead of time. So this flags risks associated with various drivers, so not just climatic. It also includes political drivers, economic drivers, health and conflict. And importantly, this product monitors how these risks change over time. So this is a fantastic example of where weather and climate risk is really one piece of this larger puzzle that humanitarian actors are having to deal with. And it's recognizing how we work in that space in a more transdisciplinary way. And lastly, on these longer timescales, we have supported preparedness activities within FCDO ahead of the 2023 El Niño event that was declared last year. So through co-developing plausible scenarios of what the state of El Niño could evolve to be, and also looking at the downstream impacts of these scenarios, preparedness activities within the humanitarian space were able to happen prior to this El Niño being formally declared in July of 2023. So this then meant that humanitarian teams in post, so in the countries that FCDO are involved in, had early awareness of this developing El Niño and the relevant impacts to their country. And this resulted in resource being able to be pivoted, resource in terms of funding, but also resource in terms of materials as well, and aid material. They were pivoted well in advance of the El Niño actually driving any of this impact to reduce the risks of these potentially catastrophic El Niño-induced weather impacts. And the main region where we saw this happen quite clearly was in East Africa. So there was a very strong signal that the El Niño would drive above normal rainfall, particularly in that short rainy season of October to December. And what we saw in post was that shifting and diverting of funds, particularly for Somalia, so that they could prepare in advance of the catastrophic floods that did end up happening. But the impact, we are hoping, would have been quite a bit reduced from having that awareness ahead of time. So each of these examples highlight the importance of user-informed and co-produced weather and climate services, as well as the need to iterate and adapt these services as different contexts emerge. So I thought we would just kind of highlight some of the successes and challenges that we were able to identify through this process. But of course, this is not an exhaustive list by any means. I wish we could keep it to 3 challenges, but we never like that in the real world. But some of the common successes that we were able to identify through this work include the ability to distill multiple lines of evidence into tangible, actionable information. And this really showcases the fact that the tailoring of science for decisions is a science in itself. And we really need to be more capable in that space, I guess, in terms of recognizing that climate information is just one piece of that much bigger puzzle. We've also been able to show the benefit of working across disciplines in a way that brings together both scientific information providers and users to explore that decision space together. And linking in with Emma's keynote talk earlier, we've learned that acknowledging uncertainties and anchoring that uncertainty in the here and now, particularly when forecasts and predictions are uncertain, is well aligned with the capability and levels of understanding in that humanitarian community. And lastly, another success is timely response is possible with the right mechanisms in place. And this is not just mechanisms in terms of funding, but also appropriate mechanisms for operational delivery of these services. On the other hand, some of the common challenges we found include the fact that the process of co-production is very time intensive, and it requires buy-in from all actors involved. And linked to this point, reflection and iteration is often lacking due to the responsive nature of humanitarian work. So as scientists, we're often drawn to that desire to reflect after an event on how action was taken, how the scientific information was understood. But the sad truth is that humanitarian actors have usually moved on to the next humanitarian crisis. So finding that appropriate time for reflection, particularly in that humanitarian space, can be tricky. And lastly, truly seamless support across time and space, such as including antecedent conditions or what's happening on the ground, near-term predictions and far-term projections as well, this is really needed to ensure that action taken now in advance of current extreme weather events is also going to be building long-term climate resilience for how those weather events will change in the future. So last slide from me to summarize, really, supporting anticipatory action to weather and climate disasters requires that tailoring of science to decisions and the co-development of actionable services. Many of the services showcased here are in continual development, and we are trying to iterate on them in slower time where we can. But the need for action-oriented research to underpin these services has become a key pillar of activity within one of FCDO's very large climate research programs, which is the Climate Adaptation and Resilience Program, or CLARE. This is jointly funded by FCDO and the International Development Research Centre, or IDRC, in Canada. And we're hopeful that the underpinning research that we're funding through this program will really be able to help drive that much more tangible, actionable early warning support in future. And that was it for me. So thank you very much for listening. And I'd be very, very open and welcome to comments and suggestions for how we can take this work further. Thank you.
Thank you for great presentation. Yeah, the echo is gone now. So yes, it seems that there is a few questions for you in the chat, Tammy. And the first one is from Brian, asking about sustainability purposes and what mechanisms are put in place for the local Met offices to be able. Oh, I'm sorry, this one is from Everisto. I'm moving one up. Sorry. So Tamara, did you assess the outcomes of your advice on Freddie? And were actions taken that demonstrably reduced the negative impacts on landfall?
So it's a really good question. Thank you, Brian. So this one, it links back to that tricky point that I raised, particularly it was Tropical Cyclone Freddie, where we were really wanting to assess how that information had been applied, particularly as we had iterated on that bulletin 7 times within that single tropical cyclone. We did receive some really useful feedback from people in post on how the information was shared, and particularly which NGOs received that information to then enable them to divert resources in particular places. It's been harder to quantitatively pull that feedback together, though. So at the moment, we're stuck in a little bit of limbo with that one, and it again kind of hones back to that challenge of measuring the impact in this humanitarian space when the people that you're working with have so very clearly moved on to the next issue. But it's something that, well, I'll take that one away.
Okay, so then to the question from Everisto, and I think it also more or less overlaps with my own question, and it's about the sustainability in terms of mechanisms which are put in place to for the local Met offices to be able to take over the responsibilities that you're taking now in the pilot project. And my question was also about your collaboration with the local Met offices and how that maybe facilitates well, capacity for them to actually provide the information that you're providing now in the project. So
yes, this is a really, really good question, and one that I think FCDO takes very, very seriously in terms of how are FCDO enabling the capacity and the capability within countries and within regions to be built up to meet this need, rather than having to always go back to I guess the global north scientific institutions that, you know, operationally we don't have that local knowledge on the ground. One program that's probably worth mentioning here, again funded through FCDO, is the WISER program, so the Weather and Climate Information Services program, which has a lot more focus on building up that national and regional capacity on the ground in order to enable this sort of pull through of their regional authoritative advice and voice into this process. So I guess one example would be with the flooding project. I'll pick on that one in particular. Even though our technical team is very much sat within the UK for delivering this flood bulletin, where we can, and particularly with Freddie, we did try to do this as well, with La Réunion being the authoritative voice in that space, we held informal engagements with those organizations to make sure that what we were putting out into that space wasn't inconsistent, because that's the last thing that we want to do in terms of providing weather and climate support is put something out into that space that is then going to confuse users downstream as well. but it's a challenge for these sorts of projects. And I think where, I'm going to put my Met Office hat now on, where the grey zone is, I think, for how FCDO support works, is that it is technically UK government. So if it's a UK government support to the UK Met Office, that's an appropriate route to take. But it's when that information and guidance starts to go beyond UK government that you really need to start thinking, okay, well, what about that? Where is that regional authoritative voice coming in? And in an ideal world, I think from a Met Office perspective, we would want that coming in regardless, whether it was UK government or not. So I think it's a really important point. It's one that FCDO recognize that sometimes responding to the here and now and providing information when it's needed now you have to have that in the back of your mind that, well, how are you enabling that to happen in region, in country, in the future without any meddling from us?
Yeah, definitely a challenge, but a real one that that we need to consider all the time, I suppose. So before we close off this this second part of our session, there's one final question, a more technical one from Damien Barantjev about the vulnerability factor when tracking the impact of a tropical cyclone and how you considered it, and what kind of factors, parameters you combined, and maybe in a total result. Can you give a quick answer on that before we move on?
I can try. My answer might be I'll need to go back to the Fathom experts and ask them. But the impact factor, the main aspect that I think goes into that process is the population exposure. So we need to have really up-to-date, really targeted population exposure for where that landfall is going to happen. So that gets incorporated very much into that flood inundation modeling side of things. But beyond that, I would have to divert to Jeff Neal at Fathom, which I can do in slower time.
Yeah, so maybe that is something to follow up, or maybe Damon can send you an email, and then some additional details can be shared if needed. So thanks a lot, Tammy, for this presentation, and I want to thank all of the presenters, both joining live and joining by recorded presentations, contributing to this great session so far. We are now moving on to Gather Town, and I think the organizers of the conference are sending the link in the chat. I see Marion has shared it right now as well. And this is a more informal space to discuss maybe some follow-ups with the presenters, but there are also 6 posters in the room. And I think we want all the presenters, if they are here now, to move to their respective posters, and then we can join for who is available in the room. And I think what we will try to do is gather around each of the posters and give it sufficient time and attention and hear what each of the presenters has to talk about. So we have 6 presentations, and there's hopefully enough time to discuss all of them. So for now, I want to thank you and for joining, and see you hopefully all in Gather Town. And of course, don't forget, tomorrow at the same time, there is another session of this conference, and it will be starting again at 7 UTC. So hopefully, if you're not able to join Gather Town, see you tomorrow morning in Zoom. And we will use the Zoom link throughout this week. It's the same one. So if you were able to join today, you're able to join with the same link tomorrow. So thanks for now, and see you in Gather Town.